dirt road in a gooseneck, saddle up with me. Dry land in God's country, crops far as I can see. Headlights on both ends of my day. This country life is for me. Ride with us, HPJ. Ride with us, HPJ.
Well, welcome everybody. My name is Jennifer Latsky, and I'm the Associate Editor for High Plains Journal. And welcome to this second session of High Plains Journal's virtual Alfalfa U. Today's session will feature Jeff Whitworth of Kansas State University with some advice on how to keep fall army cutworms and alfalfa weevils from eating those profits in the field. We'll have Dan Undersander, forage agronomist emeritus of the University of Wisconsin, helping us capture the value of our protein and our alfalfa for our dairy customers. After our mid-session break, we'll return with Mike Brook, Kansas State University, who will share some cutting-edge research into the effects of pre-cutting round bales during baling and how that affects forage quality and processing time. And finally, we'll wrap up today with Casey France, Agronomy and Account Support with Ward Laboratories Incorporated, with a presentation on why alfalfa may just be the solution for our marginalized soils. You know, High Plains Journal has been providing these Alfalfa U seminars for 6 years now. It's one of the ways that we're investing in you, our neighbors, and your future. But we know that the next generation of farmers needs help too. And that's why now until April 30th, High Plains Journal will donate 25% of every subscription sold to a state FFA organization of your choice. So visit hpjsubscribe.com/FFA and help a chapter near you. Again, that's hpjsubscribe.com/FFA to help a chapter near you. We know that education for alfalfa growers is so vital to your bottom lines. And that's why we've lined up the speakers today and in all 4 of our sessions who are going to help put dollars back in your wallets. So mark your calendars now to return for our sessions March 4th and March 11th. You'll receive reminders and webinar links to each of those sessions in your emails if you're a registered attendee. And if you missed our first session, February 16th, we'll have that recording up as soon as possible at hpj.com/alfalfau. You know, we couldn't do events like this, whether in person or online, without the tremendous support of our sponsor partners. And we want to thank our premier sponsors, Alforex and John Deere, and our associate sponsors for this session, STAHELIWEST, American Ag Credit, and Ward Laboratories Incorporated. Thank you so very much, folks. Now, I'm sure many of you have had some experience with the Zoom webinar platform over the last year, but for those of you who may still be unfamiliar with how this is going to work, let me share some notes. First, we've already muted your video and microphones, and we ask that you go ahead and keep those muted throughout the presentation. To ask questions, and that's why we're here, right? We ask that you click on the chat box at the bottom of your Zoom screen and type your questions in the pop-up box that appears. We've built in plenty of time to ask questions during the webinar because this day is, of course, about you, the producer. And you can type those questions in at any time, and we'll get to those in the Q&A after each speaker. By the way, we know that many of you are probably in the midst of extreme sub-zero conditions, and there may be rolling blackouts in your areas at any time. They might actually affect our own operations here too. So in case of any unexpected interruptions to our session today, we want to remind you all of our sessions are being recorded, and those recordings will be posted soon after we're done. And you'll get an email notification when those recordings are posted. Finally, for those of you who are needed of CEU credits, at the end of this session today, please contact Kylie Reese at 620-227-1834. And we'll make sure that that information is in the chat box throughout the day so you can copy that down. Now, before we get started with our first speaker, here is a word from our sponsor, Alforex Seeds, And joining us is Doug Bastian, North America sales leader for Alforex Seeds. Doug, welcome to the broadcast.
Thank you very much, Jenny. My name is Doug Bastian with Alforex Seeds. I'm the North American sales leader. We're one of the proud sponsors for Alfalfa U, and we take pride in knowing that we can be there to help support. And at the end of the day, we look forward to the continued success of Alfalfa U. We also would like to share that, if there's additional questions that you have with regards to alfalfa, these are some great speakers that you can communicate with. And also you can communicate with our sales staff and also our dealers across the country. Please take and enjoy these sessions, and we look forward to the continued success of Alfalfa U.
Cornish, General Manager of Alforex Seeds, one of the co-sponsors of Alfalfa U. I'd like to personally welcome you to Alfalfa University this year, and I hope that you'll find the information in Alfalfa University to be useful, informative, and that you'll take it back to your own farm or to your customer's farm so they can be more productive when coming to raising alfalfa. Alforex Seeds prides itself in having over 300 distributors and dealers across the U.S. representing the Alforex and Dairyland seed brands. Now, we realize that there are a lot of choices when it comes to purchasing alfalfa seed. But we feel at Alforex Seeds, with our focus on alfalfa and other forages, that we break ourselves out of that pack. We also pride ourselves on our variety development process. With our connection back to Corteva Agriscience, our parent company, who is running one of the world's largest alfalfa breeding programs. This provides us an excellent opportunity to test and to research a wide variety of genetics to develop really great products. Alforex Seeds, in combination with the Dairyland seed brand that we support, we have one of the largest portfolio of products in the market today. But don't take it from me. Why don't we take a little bit of time and listen to some of our very satisfied customers and how our products performed on their farm. Again, welcome to Alfalfa University, and here, let's take a listen to some of our customers.
Justin Pitch stated, our dairy cows love Hygest 660. We green chop everything, and we like that it holds forage quality well after bloom. Plus, we like the fact that we can use lagoon water for irrigation without any effect because of its salt tolerance. It's the best alfalfa we have ever produced and would recommend to all producers looking for a boost in their operation. Eli Bailey stated, once we got the water and fertility right, it seemed genetics was holding our growers back. But as we have moved to varieties like 429, growers are getting more dairy quality hay and upping their yields too. Kist shared, this is my first time planting alfalfa. I chose rugged alfalfa for grazing our cattle, knowing that we had saline issues with the pasture and on average received very little rainfall. We are happy with how it's performing for grazing cattle in the first year with almost no rainfall. Adam stated, "Stand establishment of 4400 was the best I've ever had in my years of farming. I was concerned with the hot, dry weather that the stand would not be as good as it turned out, but all in all, I am very pleased with the emergence and regrowth. For first season alfalfa, it yielded and tested very well. 4400 is everything I hoped it would be so far. I anticipate a very good crop this year and for years to come."
Well, thanks so much for that message, Doug and Alforex. And later on in this session, we'll hear from our other premier sponsor, John Deere. And remember, you'll be able to find more information about our sponsors and the services and products that they have to offer in your registration packet and materials that were emailed to you this week. You can also find more information online at hpj.com/alfalfau. Well, now it is time to get started with our first speaker, Dr. Jeff Whitworth. Through his work as Associate Professor of Entomology at Kansas State University, Dr. Whitworth's specialties include integrated pest management of row crops, household and structural pests. You know, it can be so frustrating to watch fall armyworms and alfalfa weevils eat up profits in the field. Here's Dr. Whitworth to help us control these pests and put dollars back into our wallets. Dr. Whitworth, Jeff, welcome, and the screen is all yours, sir.
Great morning to talk about alfalfa or any crop since we're pretty well frozen up. I really like doing alfalfa research. It's one of the first crops we have every year to break dormancy, that and wheat, naturally. And it's a great place to look for pests and other insects because it's a great source for all kinds of insects. So as we go through this, if anybody has any questions, I'm very informal. Just let me know and we'll try and answer all the questions. That's what it's for, okay? Okay, just what I was saying, alfalfa is a great refuge for many insect species, especially early and late in the growing season before and after the cuttings. You know, that's where a lot of insects, mites, other arthropods overwinter is in the alfalfa canopy, especially if it doesn't get cut too late in the year and there's a nice canopy there. That's why a lot of people get excited because the insects are flocking into their alfalfa. But you want to make dang sure, as it shows here, that you know the difference between beneficials and pest insects. Throughout the Midwest, primarily there's three insects that we consider, you know, occasional or perennial pests. The army cutworm, which we really had problems with in 2020, alfalfa weevils every year. Alfalfa weevils are our number one potential pest every year throughout the alfalfa growing region, and potato leafhoppers. Potato leafhoppers are an intermittent problem, but I think they're more of a problem than we generally consider them, or than we give them credit for, or that we pay attention to, however you want to look at that. And there's a variety of other pests, as you can see here. There's 3 or 4 different types of aphids, alfalfa caterpillars, we'll talk about that in a little bit, blister beetles, etc. You can read those. But those are what I consider the 3 primary problems of alfalfa that we need to look for every year, and the others can be a problem occasionally. It just depends on the weather. Remember, weather allows insects. It allows their growth and development. I've gotten several calls in the last week or two about, you know, how this cold weather is going to affect insects, especially alfalfa weevils, just because they're one of the first insect problems that we see, and that is a consideration. So first of all, I want to talk about the army cutworms. Army cutworms, they're one of the most unique insects that we have, and they're a problem occasionally, but they're really a unique insect. As you can see here, the moth or the adult migrates from the Rocky Mountains in late summer, early fall, again, depends on the weather. And they start laying eggs as they migrate east out of Colorado, in our case, out of the Rocky Mountains. They actually, over summer, above about 3,000 feet, and they over summer under logs, rocks, etc., wherever they can. They just don't like warm conditions. They're a cool weather insect, and we've made several treks to the Rocky Mountains to look for overwintering adults. And some years, I mean, they're all over. They're on every rock you roll over. There's 15 or 20 of them, or logs. And I've even seen a National Geographic special where bears are up in the mountains rolling over rocks in other states and eating the adults because they're so high in fat content. But anyway, they're as you can see, I think they're a pretty neat insect. So they move from the mountains, the adults do, and they fly. Now remember, this is just a little moth, a very fragile moth. And they fly, and as they fly east, they deposit eggs. So it depends on the weather, how far west or how far east they get from the mountains, okay? Primarily the damage that we notice is in the spring, but those larvae are there in the fall. The reason they don't cause much of a problem in the fall, because they're small. Also, the weather starts getting cool, and they go into dormancy. They really don't go into what we consider to be a full hibernation mold or diapause, but they just go into dormancy. This is a mature army cutworm here. This is it's fairly nondescript. It's very robust or fat. After about 3 weeks of feeding, they consume more plant matter or material as they get larger, as most caterpillars or larvae do. And they usually pupate or finish feeding in the middle of April. Again, it depends on the weather. Weather, remember I said weather allows insects or controls their development within a certain window. So depends on it. Every year's a little bit different for all these insects, but this is kind of the generalized biology of the army cutworm. This is the position we usually find them in. If you're out checking around your wheat or your alfalfa or your whatever plants you're looking for army cutworms in, because they have a wide host range. They'll feed on whatever's green in the fall when the moth flies back to deposit eggs. That's what that cutworm larva will feed on. They'll feed on grasses if there's green grass in golf courses, whatever it is. Anyway, if you're out searching in the soil in your alfalfa field, this is the position you generally find them in. They're hiding in cracks, crevices, under residue, etc., in the soil during the day. If it's a real cloudy day, they may be out feeding, but generally they're a nocturnal feeder. So the easiest way to find an army cutworm infestation is look for flocks of birds feeding in an alfalfa field or a wheat field or whatever it is, because I don't know how they find them. They're really attuned at finding army cutworms, and they must taste pretty good because they go after them pretty well. And even skunks. Last fall, my grandson and I were out looking, and we saw a skunk out in the alfalfa field searching around. It wouldn't leave. Pretty soon it wandered off, and we went over there and dug around, and that's where we got these pictures. It was full of army cutworms. This is the moth. This is the army cutworm adult, and this is what you generally see. This is the position, when you find them in the spring. They're called miller moths when they're flying around lights, or if you tip over something and a whole bunch of moths fly out. That's probably the army cutworm moth, the adult, and they're often called miller moths. And or they will die. They just expire in the spring. In the fall, and this is what the position you usually find them in. They'll be attracted to lights after they've laid their eggs, but they just expire, and you find them in this position. Otherwise, in the spring, when the adults come out, this is what you see. They'll come out and they'll dry out their wings or blow out their wings so that they get ready for the migration, in our case, mainly back to Colorado. Again, like I said, they oversummer out there, and then they fly back in the fall to lay the eggs, and they just expire. The adults just die after they've oviposited their complement of eggs. And they can lay a lot of eggs, 200 to 400 eggs. This is typical of the damage. I was in Oklahoma during this time, so I got these pictures in Oklahoma State. This kind of gives you the treatment threshold, but again, it depends on the condition of the alfalfa, condition of the wheat, etc. But the second bullet point here is really kind of amazing, and we don't know why. Don't explain it. We just put it out there. Outbreak years generally are preceded by dry July. If you look at 2020, we had a very dry July, and in the fall was relatively wet. And I don't know if that's the generally dry July doesn't have anything to do with the oversummering of the moth because they're in Colorado, but it might have to do with the following fall that might be a little wetter than normal, and therefore we get a little more growth. I don't know. We don't know. Anyway, we've noted this over the years that this is pretty much the case. And this is one of my favorite pictures. Last spring, after turkey season, a turkey hunter sent me this picture, and he had just successfully killed a turkey, and the turkey were out in an alfalfa field. And when he went to clean the turkey, the crop was full of mature army cutworms. So that just it goes to show you that I don't know how the birds are so good at finding these things in alfalfa or wheat fields, but they're really good at it. And this is a great picture. Now, some of my grower friends didn't want me to show this around because they thought maybe the Fish and Wildlife folks would say, okay, we can't shoot turkeys because they're good at controlling biological control. But I thought this was really kind of neat. So anyway, that's kind of the story with army cutworms. I don't know, every 7 or 8 years we have problems with army cutworms, but there's always a few around. It's just those years when the weather allows their populations to expand. And they don't, like I said, they don't diapause in the winter. Anytime the temperature's over like 48, 50 degrees, 45 degrees, they will feed a little bit, but normally we don't notice it until the alfalfa breaks dormancy. And then if they're feeding and as they grow, we can notice the alfalfa going downhill. Lots of times you get out and look in the soil, it's army cutworms. So they are a really unique insect, but they can also be a problem. They were a real problem in 2020 in the spring, around at least clear over to about, maybe the middle part of Kansas to about 81 highway, I guess. I-35 goes up to the middle part of the state, or maybe even a little east of there. They were a real problem. So anyway, that's army cutworm. Now to the alfalfa weevil. The alfalfa weevil, as you can see here, is different stages. We've had several research projects looking at alfalfa weevil, various aspects of it, because like I said, it is the #1 defoliator of alfalfa. Generally, if you don't control alfalfa weevils early enough, you're donating part of your crop to the alfalfa weevil, and we don't like to do that. So as you can see, the eggs are kind of a yellowish orange color. Then the larvae hatch out and they cause this little pinprick holes in the alfalfa leaf or in the terminals. And then they feed for a while and then they pupate, and the adults can also cause problems. So we'll go through that. Anyway, alfalfa weevils, this is kind of a generalized life cycle. You got to realize every year is a little bit different, but this is pretty much the way it goes. The adults actually mate in the summer or into the fall, and they lay eggs. They lay eggs in alfalfa stems. The alfalfa stems can be vertical or they can be horizontal. Generally, they lay them while they're vertical, and then they fall over sometimes, or they're cut off or whatever, but the eggs are still going to be viable inside those stems. We've sampled many thousands of stems over the years from all different types of places, and those eggs are still, it's tough to kill the eggs because of temperature. But that's how they overwinter, is generally in the egg stage or the adults, mostly the eggs, but there'll be a few adults. Then after the winter, early spring, the eggs hatch, the larvae become active, and they will feed anytime the temperature's over about 45 or 48 degrees, as you can see here. The thing is, I have seen eggs hatch the first part or the last part of February, first part of March, clear up through April. So again, it's all depending upon the temperature when those eggs hatch or when they're deposited into the stems. That's one of the reasons why it's very difficult to time insecticide because you're not exactly sure when those eggs are produced. The adults can lay eggs in the fall, in the winter, clear up until the spring. So it's kind of difficult, but it's not impossible. So as you can see here, I like showing this slide. This, as you can see here, this field shows, you can see the red flags there. Those are some insecticide plots that we had in this field, and the grower had the field treated around the exterior of our plots. You can see here, I'm really proud of the commercial applicator that did this, because he did a perfect job. As you can see, perfect straight line, fighting wind and everything else. And you can see this was 3 days later after they treated our field, and we went over, and I always like to wait a few days after they've commercially treated around our fields in case there's any drift into our plots, because that will skew our results. So this is the kind of damage that alfalfa weevils can do in 3 days. That's 3 days. That's just amazing. Here's a show from, or a slide from last year. Again, this is just amazing to me. You can see over here on the good one on the left, it was treated, that alfalfa was treated in a timely manner. It looks really good. The alfalfa on the right, just a few miles away, it was treated, but it was treated like 3 or 4 weeks later. They asked me if I recommended they treat it, and I said, no, there's no reason to. The larvae were already mostly in the pupal stage, but they went ahead and treated it. But you can see the difference when an accurately timed insecticide, how it works versus being delayed a little bit. And you know what? A lot of times, that's one of the problems we have in the spring is the weather. You know, it can be windy, rainy, cold, snowy, whatever. But this is what that kind of damage looks like up close if it's untreated. These larvae just totally skeletonize these plants. I mean, most of you have seen them, but a lot of times you see it as you drive by. It just looks a silvery color, but that's what it looks like up close. So, yeah, alfalfa weevil, the larval stage is the stage that causes most of the problem. But some years, if it's cool enough, the alfalfa weevil and the honey cutworm, they're both considered cool weather insects. They generally affect the alfalfa early on. But sometimes if it's cool enough into the spring, the adults can hang around, and sometimes the adults can cause problems. This is what, it always amazes me how the growers don't really realize what an adult alfalfa weevil looks like. And they can, they've seen the larvae, the little green worms. They don't realize those worms pupate and then turn into this little adult weevil. And sometimes these weevils can hang around into the spring, and I've seen them into June, even in the cool summer, and they will do what they call, they'll feed around the epidermis, around the outside of a plant, and they do what we call barking on the plant. And usually it doesn't cause much of a problem, but occasionally, if there's a lot of it can. Or if there's enough larvae around and enough adults, when you go out to harvest your alfalfa, and you accumulate all those adults and all those larvae as you harvest it, and you put it in those windrows, those adults and some of those larvae can still feed for 2 or 3 days underneath those windrows. That's why you'll see this typical striping of the fields. And 2012, we had a really bad year of alfalfa weevils, and we saw a lot of this. Even though the insecticides work, if you get 90 to 95% control with an insecticide, generally that's considered pretty good. But 1 to 10% even of alfalfa weevil larvae and adults, as you accumulate them, concentrate them underneath these windrows, when you're swathing, it can cause problems like this. So the problem just kind of snowballs on you from there. But that's generally one of the problems. You get 90, 95% control, even if it's well timed, and then you can have this problem. The weather effects, remember, insects 100% controlled in their development by temperature. So that's one of the problems we have, trying to control larvae in a good manner, because like I just said, we have, weather conditions in the spring can be cold, can be hot, can be windy, can be rainy, can snow, sleet, rain, whatever. So even if you have nice 70-degree, no wind conditions, it may have rained for a week and the ground's too muddy to get on. So, that's one of the problems we have with controlling alfalfa weevils in the spring. And I really do not like alfalfa weevils for that reason. They're real difficult to control just because of the timing of the thing. In 2016, we found larvae, as you can see here, we found larvae in November. Now, I just told you earlier, according to the generalized biology of the alfalfa weevil, in October, November, we're seeing adults and eggs only, but that's generalized. In 2016, we have a really warm fall, and we saw alfalfa weevil larvae hatch out and mature. Now, I don't know if they actually survived the winter or not. We couldn't follow it through, but we did find them. So, they do change a little bit. 2018 was the third coldest April on record. And, the question I get is, how does cold spells affect insects? If they're in their diapause or dormancy period, generally doesn't affect them. But if we get cold weather after those eggs hatch, remember the eggs and the adults are the overwintering stage. If we get egg hatch and then we get below freezing temperatures into the mid-20s for an hour or two, it will kill the larvae. And we saw this in 2018. We saw it again in 2020. So you have a period of cold weather, and then period of warm weather, the eggs hatch, and there's small little larvae in the terminals. And then we got cold temperatures, and it got down into the mid-20s or lower 20s. It killed the larvae. You can see the little black larvae, and some of the others were moribund. That means they're going to die. So that really helped in 2018 and 2020. And both years, in the fields I looked at, we never could rebound, or they never did rebound into treatable populations. We were looking to treat some or to test some new insecticides. So that can happen. So cold temperatures, it depends on, again, the timing of where they are. Now, alfalfa weevils, we have a publication that you can download for free. Just go to KSU, as you see at the bottom, KSU Extension Entomology, hit publications, hit crops, hit alfalfa. We have this publication you can download for free. It tells a little bit about the biology of the alfalfa weevil. Plus, we've developed a growing degree day system. Most people are familiar with that with corn, soybeans, other crops. Same exact methodology involved. You find out what the temperatures are that affect alfalfa weevil development, and you try and relate that to the ambient temperatures of the day. So you can see how many growing degree days or thermal units it takes for the eggs to hatch. Now again, we have this developed, and it's available on the MesoNet, but it starts from January 1st. And some of these eggs are laid, like I said, in October and November. If we have a warm year, they can have developed quite a bit. So it's not perfect, but it's pretty close. We tested it over a period of about 5 years. This is what you see on the MesoNet. You can just go to the site nearest you, click on that, and it'll show you, in the alfalfa weevil, will show you how many growing degree days or thermal units have accumulated up to that point in time. So it's really kind of a neat little service that the KSU MesoNet folks providing for us. But they change a lot, so you want to make sure you go to the weather station nearest you. They can change a lot, like within a county or two. So the weather does. Potential control options for alfalfa weevils. We've tried just about everything, and other folks have tried just about everything. 2016, I throw this up there because this is the last time we actually had a full-blown insecticide trial. As to my knowledge, K-State, we haven't been given any new insecticides. 2018, we had a bad year. 2020, we had a bad year because of the weather. So you can see that the insecticides work, but again, it's all about timing and making sure you use enough carrier to get the insecticide down to where the insect is. You got to get the insecticide to where the insect is in over a period of time. Remember, I said spring applications can be very variable because of weather conditions. So we tried fall. If you think about it, right, in the fall, according to the biology, all the insects should be in alfalfa fields as adults laying eggs. So they should be mostly in the smallest population, and they should be localized in just alfalfa fields. So we tried treating alfalfa fields in the fall in order to kill adults before they lay eggs. Now, one of the problems is, how do you time that? These insecticides may last 2 to 3 weeks. And if, how do you time it? So we timed it by when we found the first adults that came back into the fields. And you can see the results here that we got. Fall chemical applications, and we did this 2 years, large scale applications, because we're really trying to find something better than just the old spring application. You can see here, from a statistical standpoint, yes, the fall applications work, but from a practical application, they did not work, because in the spring, which is what we're concerned about, the populations of alfalfa weevils still exceeded our treatment threshold. So yeah, it did not work in a practical manner. So other things we've tried over the years, we've tried crushing. A lot of people, I get lots of calls about, whether you run cattle out onto the alfalfa, if that will help crush eggs, because what you're trying to do is reduce those eggs for the spring, so there's not too many of them hatch. Shallow disking, harrowing, all this works. If it works for you, go ahead and do it. But it doesn't work consistently in our trials that we recommend it. Grazing, like I said, under correct conditions, under the right conditions, it can work, but it just doesn't do it consistently enough for us to recommend it yet. If you do it and it works for you, do it. Go for it. Again, burning for alfalfa weevil control. We've published this a couple of times. This is an example in spring of 2017. Pretty good burn on this alfalfa field. And we went back and sampled it when the alfalfa broke dormancy, and after it had grown a little bit, and the alfalfa weevil still exceeded the treatment threshold. So we actually had the idea of getting a bunch of waste cooking oil from McDonald's and other places, kind of make it green friendly, EPA friendly, and use that as a burning source. And we did, and it works, but still doesn't control, and it might help with weeds, but it didn't control the alfalfa weevil below the treatment threshold. So anyway, we're more than willing to try just about anything, because the alfalfa weevils, again, if you don't treat for them, generally speaking, you're donating pretty good, healthy part of your first cutting to the alfalfa weevils. So that's the story of the Army cutworm, alfalfa weevils. Those are our 2 pests that we have, especially alfalfa weevil. The third one of the big 3 that I want to talk about quickly is potato leafhopper. Potato leafhoppers don't overwinter in the Midwest, and they overwinter in the southeastern part of the United States. They mainly fly in or migrate in or are blown in, whatever the case may be. However they get here, they do get here. We have 2 to 3 generations a year. They have a very small or very low treatment threshold, which means it doesn't take very many to cause problems with your alfalfa, because they cause problems 2 different ways. Number one, they feed by sucking the juice out of the plant. And as they do that, they introduce a toxin into the plant. So that's why we get this characteristic coloration, and we call it hopper burn. And if it's bad enough, especially if it occurs late in the summer, early fall, it can hurt the crop, stress the crop enough going into overwintering that can really be a problem. So this is, they're in every field every summer. I just don't think we pay enough attention to, but this is what we're starting to see recently in mid to late September. And if this occurs and you don't get a cut, again, these potato leafhoppers are hanging around before they go to the southeastern part of the country to overwinter. They cause damage, and this just hurts the ability of the plants to overwinter, to put the nutrients into the root system for overwintering. So those are the primary big 3 we talk about. Some of the other pests that I get called on a lot, aphids. Alfalfa caterpillars, blister beetles. I'll go over those real quickly here. There's several different kinds of aphids. Okay, pea aphids are the ones that come on early. Now, the reason I want to talk about these is because a lot of times, this is the largest aphid we have in alfalfa, and a lot of times they're there early, like I said, in the spring, and they are a food source for beneficials. So they help the beneficials build up early in the year. And then we have cowpea aphids. Cowpea aphids usually are a warmer weather type of aphid, but they have a lot of honeydew, much like sugarcane aphids do on sorghum. They produce a lot of honeydew, therefore you can get a black mold or black fungus growing on that honeydew. And a lot of folks, as you can see, that can interfere with photosynthesis also. And then we have the spotted aphids. They come along in the summer. Again, I've not seen them cause problems, but they do around in different places. Not so much in the center, in the Midwest part of Kansas, but they like hot, dry conditions also. And again, their feeding can cause a toxic reaction to the alfalfa plant. Now, this is the problem. 2018, we had a cold spring. 2020, we had a cold spring. We didn't have an alfalfa weevil problem, but we had a lot of pea aphids. And a lot of producers were wondering whether to spray for pea aphids or not. So that was a dilemma. Because if you spray for pea aphids, generally by the time those populations build up, we have a lot of beneficials out there, a lot of pollinators. The plants are starting to flower, so you're going to kill a lot of beneficials also. So that is a problem. That is a consideration. These are the lady beetles, or the beneficials that we normally have in our alfalfa. And again, I show these because a lot of folks don't recognize these. These are lacewings. They have the eggs. They're up on stalks, up off the leaf, and then they turn into what the little larva looks like a colored alligator, and then they'll turn into the adults, which are flying around. Those are beneficials. The alfalfa caterpillar sulfur butterfly, I show this because every year I get calls about these adult butterflies flying over alfalfa fields. They'll fly over alfalfa fields, soybean fields, whatever, but alfalfa is the one that's mostly of concern. And I've seen folks spray for them before. They'll spray for when they just see lots of adults because they know the adults are laying eggs. And they do. That's what lays the eggs. And they turn into these alfalfa caterpillar, which are green, velvety colored larvae. I've found some in alfalfa, even with thousands of adult butterflies flying over the fields, but I've never seen them become a problem in soybeans or alfalfa. I know others have, but around the Midwest, the central part of Kansas, I've not seen them really become a problem. But they can be concerning to folks. Then blister beetles, get calls about those all the time. They're the only problem they produce is because of the cantharidin or the blistering, as you can see here. They do blister. I've had those on me before, and they cause that blister just instantly when they release that cantharidin. But you got to remember about blister beetles. If you have a lot of blister beetles, there were grasshoppers there because the blister beetle feeds on grasshopper eggs, so they can be a beneficial also. Keep that in mind. Okay. Last, grasshoppers, they're our number one pest in all crops, in my opinion. From what I see year after year, they'll feed on alfalfa, and they can build up in pretty good numbers in alfalfa. So keep that in mind. They can be a serious problem. You want to treat them when they're in this stage while they're small. Generally, the eggs are laid in non-disturbed areas, grassy waterways, weedy waterways, and they migrate from there. So if you can control them where they're small before they migrate out, you're in better shape. And then I get calls about other insects, worms. There's all different kinds of worms. Remember, there's lots of different insects in the alfalfa field because it's a great place to harbor insects. There's a good canopy out there until it's swathed. And I get calls about tarnished plant bugs a lot and lots of different crops. They really aren't a problem in alfalfa unless you're a seed producer. And then they get up there and they can suck the juice out of the developing seeds, and they can be a problem. Anyway, we've produced 2 different books over the years. Crop Insects of Kansas, which we're getting ready just to do a second edition, and Household Pests of Kansas, which we just produced a couple years ago. This is, you can go to, like I said, Extension Entomology Overview. You can go to Efficacy Trials. We try and put those on the the results of our efficacy trials and non-proprietary compounds that we test. You go to publications. We try and keep up that all the time. So there you go. That's pretty much the story on insects, arthropods in alfalfa, at least in central part of Kansas.
Well, thank you so very much, Dr. Whitworth. That was kind of fun, I got to say. I never really. I always get a little bit of something new every time I talk to the bug guys and learn a little bit more. And it looks like we've got a lot of questions already in the chat box. But be sure to add your questions there, folks, because now is the time to pick Dr. Whitworth's brain, okay? So we'll start off. We have a question. What would you say that the threshold is for a stand that is in its second year of production versus a stand that's in its seventh year of production as far as weevils?
Well, our threshold is 30 to 50%, which means if you have one stem out of three, infested with one larva, that's when we initiate or we call the applicator. If it gets up to 50% where you have two stems out of four, we call. I mean, it's from 1/3 to 33% to 50% infested is when we like to get started treating, realizing there's more eggs going to hatch. And again, the second year, it's looking pretty good. The seventh year, again, that's up to you. That's kind of your call. I kind of use the same threshold. If it's seventh year and you're maybe not producing much, but you want to squeeze out all you can, I would go with the third, the 30%, 33%. The alfalfa weevil is going to be there. I do not like alfalfa weevils because, again, it's a matter of timing them. And don't go out there, and a lot of guys go out when they find those eggs first hatching. It's hatching early in the spring. There's not that much going on, so they're out being really good, looking at their alfalfa, trying to find those larvae when they first hatch so they can get on it right away. But you got to be a little bit patient because, like I just said, they're laying eggs in the fall, in the winter, clear up until the spring. So there's going to be more eggs hatching. And the guys always say, well, we get another flush. Yeah, that's because of the temperature, when the eggs are laid and when the thermal units are growing degree days develop. So I always use 30 to 50% infested. That's not number of larvae per plant. That's number of stems infested. And if you get out there early and look, it starts building up 10%, 15%, and then it'll usually hatch. You'll have a hatch. And I would kind of treat them all the same because they're going to build up and they're going to go fast. Even in a first year field, we found them in first year fields. I don't know. Even when they were planted in the spring, I don't know how they find them so fast, but they're really good at detecting that alfalfa and moving into it.
They must have a Twitter just for alfalfa weevils that shines a light on, kind of like a beacon, I guess.
Well, I think we ought to get them banned if that's the case. And so.
We've got another question here. Do seed treatment insecticides help with control of alfalfa weevil in the establishment year? Again,
I just go by threshold. We don't like to do it prophylactically or just in case, which, some of the growers will spray for those alfalfa caterpillars or sulfur butterflies I showed when they see the adults flying around just in case. I don't really believe in that. I really believe in getting out and looking. And I really can't go by the sweep sample by using a sweep net. I know that's the easy way to doing it. And if you find a lot in a sweep net, yeah, spray. But the way we go is by the stem count, where we pick stems, shake them in a bucket, and count the number of larvae to fall out after 10 stems or 100 stems or however much bending over you want to do. Yes, but again, every field's different. So if you plant it in the fall, especially, it could be more vulnerable. If it's planted in the spring, just get out and check and check for that threshold of 30 to 50% has been pretty good for us.
Okay. So I get to practice my pronunciation today. Any impact of using an insecticide chlorpyrifos? Chlorpyrifos. The fall prior to alfalfa going into a dormancy. In particular, they say in western Nebraska and eastern Wyoming, they've got 12 years of heavy infestations of alfalfa weevils, even when they're seeding new alfalfa.
Yes. I'm not sure what the question is. Try that again. Would you try that?
Okay, insecticide. So is there any impact of using an insecticide chlorpyrifos?
Chlorpyrifos?
There we go.
That's a common name, Lorsban.
There we go.
Is there any, now what's the question?
They're going to plan on applying it the fall prior to alfalfa going into a dormancy. And they're in western Nebraska, eastern Wyoming.
You know, we tried it 2 years. I had a graduate student working on a PhD to try and figure out fall timing. You know what? We don't even know where the damn things go in the literature, and I've written some of it. We say they go to creeks and CRP and places like that for oversummering, and then they come out of there into the alfalfa fields. We put traps up all over between alfalfa fields and tree lines and wood rows and creeks, and we could never catch any adult weevils coming back, and yet the field would be 100% infested in the spring. So, I mean, again, if you want to do that in the fall, we tried it. You saw the graph I showed that statistically it helps. But again, what we did was when we found those first adults in the fields, we went out and sampled the fields. In this case, you can sweep sample the fields because there's not going to be that many. You can sweep sample the fields. When you find those first adults, we waited 2 weeks because remember they move back to the fields, then they mate a little bit, and then it takes them a while to lay eggs. So we waited 2 weeks, and then we put out that first application. Then we did it 2 weeks after that, 5 different times. And we got statistical benefit out of it, but not a practical benefit because in the spring, you got to remember anytime the temperature's over 45, 48 degrees in the winter, these adults can become active and they can move around and they can lay eggs in those stems, and they're not, that insecticide's not active any longer. So again, if you want to try it. We tried it, but statistically it worked out, practically it didn't.
Okay. We have another question here, specifically asking about biological controls for these pests, natural predators. For folks that are trying to avoid insecticides at any cost, we talked a lot about burning and mechanical disturbances to kind of slow that down. But any other beneficials that you can throw out there?
Well, we sample every year. I showed you all the beneficials that we normally find in alfalfa canopies in the spring. Generally, they're feeding on aphids, pea aphids. I don't know if they taste better or they're easier to catch. Occasionally, we'll find a lady beetle feeding on a small alfalfa weevil larva, but we've not found any biocontrol agent, whether it's a pathogen, a predator, parasite, whatever, that's really helped a lot. There's a few, but they don't really help control the population to a manageable standpoint.
Okay.
Wish so, but so far, no.
There's got to be something out there someday, and somebody will find it. I have every confidence in that. Have you seen an increase in BAA damage the last few years?
No, I've not even seen a blue alfalfa aphid for 15 years around central Kansas.
Is thrip ever an issue with alfalfa?
Is what?
Is thrips, are they ever an issue?
No, you can find lots of thrips in alfalfa because, like I said, it's a good canopy for them, but I've never seen them be an issue.
Okay. So with the bitter colds that we've had going on right now, is that going to do anything for us, or is there anything we need to be watching for when we walk our fields?
In my 40 years of working in entomology in Texas and Kansas, no. If they're in dormancy, just like the plants, generally it doesn't bother insects. They've been here a lot longer than we have, and they're going to be here a lot longer than we are, and they've survived all different kinds of temperatures, humidities, moistures, whatever. again, if they're in diapause or dormancy, I've not seen it bother them. If they break dormancy, we get a cold spell in the spring as far as alfalfa weevils or other insects. Yeah, it will. It will help a lot. But right now, I mean, I've not. We've tried everything. Again, we flooded fields to try and get the ice down where it would freeze in December and January. It just hasn't helped, So no, I just doesn't help this time of year.
Well, if it was easy, you wouldn't have a job.
It's called job security for entomologists, I guess. You're right.
There you go. There's always something to look forward to.
Look on the bright side.
Well, now we have another question here, and we'll probably have room for just this last question. Are black aphids worse than pea aphids?
The black aphid, I'm assuming you're talking about the cow pea aphid. Are they worse? I have seen them when they come on, it's usually a little later in the summer when it's warm, and lots of times, alfalfa is generally considered a cool weather crop. So the cow pea aphid or the black aphid, they produce a lot of honeydew also. So a lot of times they're actively feeding in the alfalfa during the warm or hot part of the summer when the stress is on the alfalfa also. So you get compound stress with the honeydew and the feeding of the black aphid and the stress of the warm, hot, dry conditions. So yeah, it can be. But pea aphids, they're usually there in the early part of in the spring, late part of the winter, early part of the fall. So they can cause problems, especially in a new crop alfalfa. But I would say the black aphid or cow pea aphid has more potential causing problems, again, depending upon the weather.
Okay. We've got one more question here. Is it true that the weevil doesn't have a pancreas? Could they be slowed down if we got the Brinks index up ahead of time?
Is it true that the alfalfa weevil doesn't have a pancreas?
Mm-hmm. That's the question. And Brix, the Brix numbers in the plants, the sugar number in the plant.
Oh, yeah, I don't know. It doesn't have a pancreas. I know that. We dissect them every which way, but I don't know about the sugar level index.
Okay.
Might be something to look at.
There you go. Finally, as we're going into the season, we've had a lot of folks that have kind of talked about maybe we're in well, we know that we've had a lot of drought out our direction, a lot of drought out the western states. It may not really ease up this year. Is that something that our alfalfa growers need to pay attention to, and especially when they're scouting those fields, because we know that any stress to the plant makes it a little bit more appetizing to those critters out there?
Yeah, exactly. I mean, the more stress you have, the more potential for stress due to insects or arthropods. They just compound it, so that's exactly right. If you have warm, hot conditions, dry conditions, and the plants are under stress anyway, you might consider adjusting your treatment threshold for whatever pest it is a little bit down, and because they may not be able to handle as many as they could under good growing conditions. That's exactly right.
Okay. Well, Dr. Whitworth, it doesn't look like we have any more questions for you today, so we'll wrap this up. I just want to say thank you so much for joining us today and sharing your knowledge. I appreciate it.
My pleasure. Thank you. Good luck. Stay warm and well.
We sure will. And folks, while we get our next speaker lined up, we want to take a brief moment to recognize our sponsors for today's session. John Deere is a premier sponsor for our 2021 Alfalfa U series of webinars, and they would like to welcome each of you joining us live here today. Now, here's a short video clip of some of the technological solutions John Deere is bringing to your alfalfa fields.
Now you can get more from your mower conditioner with John Deere 0 Series mower conditioners. Cover up to 10% more acres per hour with the wider cutting width of the C500. This lets you hit tight harvest windows and increase your productivity. The John Deere 0 Series mower conditioners feature side pull and center pivot models with a wide range of cutting widths to meet your needs. Mow with a wider range of tractors and handle hills easier. Use less horsepower and fuel thanks to the lighter weight of the redesigned C400. Customize your windrows to improve dry down thanks to wider conditioning rolls. width of the windrow is critical to dry down, and the C400 lets you put down windrows of up to 133 inches wide. Many John Deere 0 Series models give you the ability for wider windrows, thanks to the forming vanes. This lets you preserve hay quality, while giving you more time to bale before Mother Nature strikes. In addition to quicker dry down times, you'll speed up knife replacement. With quick change knives, you can cut time changing knives in half. With the simple tool, you're able to change your knives out in minutes and return to cutting, helping you maintain the best cut quality. You'll also get more choice when it comes to conditioning your crop. The wide variety of models in the 0 Series let you match the conditioning options to best fit your crop and operation. For grasses and grass legume mixes, our economic impeller options fit the bill. The urethane roll is excellent for thicker stem grasses, cane, or legume crops. Two steel intermeshing options, the V10 and the Trilobe, offer durability with improved crop conditioning. John Deere is confident in the durability of its mower conditioners. To ensure you share this confidence, we've upped our warranty. Now, both parts and labor are covered for all components on the proven low-profile cutter bar for 5 years on all John Deere mower conditioners. Get more productivity, tractor compatibility, uptime, choices, and confidence with John Deere 0 Series mower conditioners.
Well, thank you, John Deere, and thanks also to our associate sponsors for today's session, STAHELIWEST, American Ag Credit, and Ward Laboratories Incorporated. And later on today in this session, we'll hear from Ward Laboratories, Casey France, on how alfalfa may be a solution for your marginal lands. And now, let's learn how to provide a little extra value to our dairy customers with Dr. Dan Undersander. Dr. Undersander is a familiar face to many of you who have joined us for Alfalfa U in years past. Dr. Undersander conducted irrigated forage research in the Texas High Plains for 10 years before moving to Wisconsin 32 years ago, where he coordinated the multi-department extension forages team at the University of Wisconsin. He conducted research on grazing, forage production, forage harvesting, forage utilization, and on near-infrared reflectance, prediction of forage quality, and other parameters. Dr. Undersander, thank you so much for joining us today, and welcome to Alfalfa U. The screen is all yours, sir. We'll go ahead and let you share.
So we're going to talk the next few minutes about the value of protein in alfalfa. And I think that this is one thing that we haven't paid near enough attention to in the United States, particularly. All over the world, legumes such as alfalfa are valued for the protein content because protein is often deficient in grass. We've had less expensive protein, but now things have changed. I do think that it is important to recognize when we're thinking about alfalfa that it has a number of values. First, we're adding fiber. And a value is that the rate of digestion is faster than the fiber of grasses, including corn silage. So we can feed some alfalfa. We can have a good level of intake, a good level of energy, but still we don't get the rumen acidosis that we oftentimes get from our corn silage and concentrate mixtures. Alfalfa is kind of a good buffer. Then because it has a higher rate of digestion, it also has a higher rate of passage, so that it is a really good energy provider for animals. It's very palatable, but again, the thing that we haven't paid enough attention to is that it's high in protein. And I know some individuals have disagreed with our relative forage quality because we're only looking at energy. And frankly, at a time like this, there's significant value to the protein in alfalfa. If we think of corn silage, the protein content is usually about 7.5 to 8.5%, whereas alfalfa, if it's put up at the bud to first flower stage, should be 18 to 22%. When we look at the needs of grazing of any animals, our milking cows need about 14 to 16% crude protein in the ration. So you can see that a high corn silage ration is going to be deficient in protein. Our steers gaining a couple pounds a day need 10 to 12% crude protein, and a pregnant beef cow needs about 8 to 10% protein. So in all cases, corn silage by itself is deficient in protein for these animals, and alfalfa, either solely or mixed with something else, will help provide those protein needs. Now, this has become particularly important in the last few months because the most common soybean supplement, the most common protein supplement is soybean meal, which has recently reached over $500 a ton. And so people are looking for alternatives to having to buy soybean meal, and the obvious alternative is to feed a little bit more alfalfa in the ration. In addition to the protein that alfalfa provides, alfalfa is high in lysine, which is one of the amino acids particularly needed by dairy cows. And of course, there's other minerals in here, particularly calcium, which is valuable for horses, and a number of other things. But let's go down and first kind of define our protein terms, because a lot of different terms are used, and I think it's important to have an understanding of each. The most common measure that we see on all forage analysis is crude protein, which is basically the nitrogen concentration times 6.25. Or if we have grain and the lab is calculating correctly, it would be times 5.7 for grain. And what we're saying is that the nitrogen concentration of protein is about 16%. So if we multiply the nitrogen times 6.25, we get a crude protein. To a ruminant animal, it doesn't make too much difference exactly what the form is. There are some exceptions that we'll talk about and some need for bypass protein. But this kind of comes back to the fact that we can feed a cow ammonia and paper, and the rumen microbes will take the ammonia and make protein out of it and digest the paper and provide energy for the cow. Now, it's not going to be a high producing cow, but it can survive on such, whereas any non-ruminant cannot. So the common measure is crude protein. Just a little bit of an alert here. One of the things that we want to pay attention to is when the crude protein is too high, that may mean that we have a significant amount of non-protein nitrogen. And we'll come back to that. But so true protein is the actual protein in the sample. The only way we can measure that is with dyes and various more expensive techniques than measuring nitrogen. And therefore, we seldom do that in either food or feeds. The non-protein nitrogen is the other kind of, quote, crude protein. And that is the ammonia, the nitrate, the amino acids, and other compounds that are quickly degraded and converted into microbial protein. As I was starting to say, one of my concerns always is if the crude protein gets too high. So for example, if corn silage is above 10% crude protein, that probably means that we actually have a lot of non-protein nitrogen. We don't see this very often in alfalfa. In fact, I've only seen it twice in the last 45 years. But if we have a good alfalfa to stem ratio and we're up above 30% crude protein, then we might think too that we have some non-protein nitrogen, either from excessive manure applications or nitrogen from various other sources. Plants will always take up nitrogen that's free in the soil rather than fix their own if they have the choice. Very uncommon with alfalfa, but again, if you see high levels of crude protein significantly above what you'd normally see, should be suspicious that it could be non-protein nitrogen. And we see this a lot in grasses and in corn silage, particularly grown under dry conditions. And then that tells me that we probably should be testing for nitrate and think about being careful how we feed this material to animals. So do be careful of crude protein that's too high, because it's likely a lot of non-protein nitrogen, which can be toxic. The microbial protein is the protein from the rumen microbes. So what happens is you feed a plant to an animal, the microbes in the rumen break down the plant material, they convert the plant protein to bacterial protein, and then those microbes eventually work into the small intestine of the animal, and they're digested just like any protein source. This can be anything from 50 to 100% of the protein required by the animal, depending on what category of animal we're feeding. The other important consideration is rumen degradation of the protein. And as we just said above with the microbial protein, a lot of the protein that comes into the rumen is digested and then broken down and moved into the cow as rumen protein. We would actually like some rumen undegraded protein, and the reason is because we want certain proteins to amino acids to bypass the rumen so that they can be absorbed by the animal. This is particularly true, I'll say it now and I'll say it again, with a lot of the sulfur-containing amino acids. Rumen-degraded protein may be fine for a lot of animals, but particularly when we get into high levels of milk production, we need a little bit more of the sulfur-containing amino acids, and the only way to get those is to have protein that bypasses or is undegraded in the rumen. We actually, in fact, see some benefit of high levels of gain in stockers to a little bit of bypass protein as well. The last term that I'll give you is metabolizable protein, and that basically is the total amount of protein absorbed by the animal. The reason that that becomes important is because in some measures, if we're monitoring carefully, we want to know how much of the protein is actually reaching the animal and how much is just passing through. So think about these terms. Crude protein is the common measure. If it's in a normal range, we're fine, we should use it. If it's excessively high, we should suspect some non-protein nitrogen and maybe test for it. And then the thing that we want to think about is the rumen degradation of the protein. Now, with alfalfa, most protein is in the leaves. The leaves usually contain about 25 to 30%, and that's why I was a little bit careful on the level that I gave in the previous slide. You have pure leaves, 25 to 30% protein's okay. But the stems contain only 6 to 10% crude protein. So if you have a hay or a silage that's about 50% stems, then we shouldn't see the crude protein being over 20 to 23 or 4%. The other thing that this becomes important is that since the main protein is in the leaves, there's a couple considerations. One is that taller stemmy alfalfa tends to be lower in crude protein than shorter alfalfa. So one of the things we oftentimes see is alfalfa grown with limited water, is a little bit shorter, tends to be a bit leafier and a bit higher in crude protein than alfalfa that has adequate water for good growth and normal height. So the problem that we have actually with alfalfa protein is that microbial protein contains less sulfur-containing amino acids than the cow needs. She needs a good level of lysine, methionine, and cysteine. if we feed, and alfalfa is pretty good in the level of these amino acids, but if we feed alfalfa to the cow and the cow breaks down the protein and makes its microbial protein, then that microbial protein has less of these sulfur-containing amino acids than the original alfalfa did. And so that's one of the things that we're looking at, is how to get more of these valuable amino acids from the alfalfa protein into the cow. And so again, as a second point there, even if the plant protein like alfalfa had a good level of these amino acids, they would be lost to the animal if the protein was degraded or digested in the rumen to make microbial protein. Furthermore, excessive degradation of forage proteins leads to ammonia nitrogen production. When ammonia nitrogen exceeds microbial requirement, it is absorbed from the rumen and converted to urea in the liver. Conversion of ammonia nitrogen to urea requires energy. Thus, urea excretion in the urine is both a metabolic burden to the animal and an economic loss for the farmer. Just a little food for thought, approximately 75 to 85% of the nitrogen consumed by livestock is excreted. This is why we like to make sure that we're using the manure appropriately, that we're recycling it, because really not that much of the nitrogen we're feeding the cow actually goes into meat and is removed, or milk. So alfalfa is more highly degradable than many other sources of protein, and this is a limitation. If you look at the graph on the right, what you'll see is that the alfalfa silage is about 75 to 90% bypass protein. Alfalfa hay is actually a little bit better, being about 70 to maybe 80% rumen degradable protein. And so this is why we oftentimes have to feed a little bit of other supplements with it. Again, I would say the major thing is to feed as much alfalfa as you can and only supplement the difference, rather than have to make up the full protein need of the animal. So how do we increase forage crude protein of alfalfa? Well, one is to cut early. The earlier we cut it, the higher the protein. When we cut at the bud stage, we should be about 18 to 20% crude protein. If we cut at the flower stage, then we should be down around 16% crude protein. The second option is to have a more dormant variety of alfalfa, but then we're sacrificing yield, and that's a problem. The last option, of course, and thing we'll talk a little bit about in a few days, is to manage the harvest to retain the leaf fraction. Since the leaves are the high protein fraction, if we lose leaves, we not only lose tonnage, but we lose protein, as well as digestible energy. If we're trying to increase crude protein, nitrogen fertilizers or manure can increase the apparent crude protein of the forage. Unless we go pretty high, we would commonly see this in grasses. Let's start with that. But unless we go pretty high in the alfalfa, since we should be up around 18 or 20% crude protein, we're not going to see much of a change. As I said, all that'll happen is that the alfalfa will use the available nitrogen and not fix as much nitrogen. When plants take up an excessive high level of protein, remember that it's not protein, but it's nitrate, nitrite, or mainly, or it could be free amino acids that the nitrate or nitrite is rapidly converted to. This additional protein from nitrogen fertilizers is generally not well utilized by ruminants on high performance diets, since it is a very rumen degradable protein. Alfalfa hay has more bypass protein than alfalfa silage. For those of you making hay for sale and selling it, that is one of the advantages to buyers, is that your hay will have more bypass protein than the alfalfa silage. The reason is that the silage making bacteria break down some of the forage protein into peptides, and then those peptides are more rumen degradable. One study found that the non-protein nitrogen content of ensiled forage was 66%, while hay was 25% compared to the fresh forage. So it can, and we'll talk a little bit about ensiling in a minute. One of the considerations is what's called the Maillard reaction, which is a heat-induced reaction that combines the sugars with the protein. And if we look at this graph here from some of the work that we did years back, what you see is along the bottom axis, we have heating degree days, and that's defined as the hay temperature above air temperature times the number of days. So if it's 5 degrees above for 1 day, that's 5 heating degree days. If it's 5 degrees above for 2 days, that's 10 heating degree days. And if you look at this graph here, what you see is that the green dots and line, the digestible non-fibrous starch, carbohydrates, which would be starch and sugars, tends to decline the more heating you have. The crude protein, digestible crude protein, the light green line, does decline somewhat. But mostly the TDN of that forage declines. So we have the heating is good in that it will help give us more bypass protein, but we are losing some energy in the process. So let me just start by saying a little bit of heating is good, too much is bad. Heating causes sugars to bind to proteins. It does increase the palatability of the forage. Anybody that's ever fed cattle knows that cattle like some heat damaged forage or heat mallard product forage more than just plain forage. And let me just quickly say, we're the same way. We like mallard products better. I mean, that's why we brown steaks, and there's a number of other examples where we kind of brown things a little bit to increase the palatability or flavor in that feed stuff. It does increase the bypass protein. However, if we have too much heating, first we'll lose a lot of energy, the digestibility goes down, and secondly, it may cause the protein to not only bypass the rumen, but pass right on out of the animal. So a little bit of heating can be good, too much is bad, and unfortunately, we really can't control any of this. So we want more rumen undegraded protein. This is particularly true for dairy cattle, and I think it's a little bit unrecognized for stockers where we want really high levels of grain. We did trials years back and found improved gain with a little bit of bypass protein for stocker animals. Protein supplements are the most expensive. Excessive rumen degradation of proteins leads to greater amounts of compounds excreted in the urine, which can be an environmental problem as well as a cost. And so we need to recognize that high plasma urea associated with extensive protein degradation in rumen cows can also cause reproductive problems. Now let's think a little bit about what we can do to increase the bypass protein. So the first thing is with alfalfa, we have a good level of protein, and we should take advantage of that by feeding a goodly amount of alfalfa in the ration. Secondly, we can do a few things and a number of things have been tried to increase the level of bypass protein. The main thing that we hear about is tannins, which are naturally occurring polyphenic compounds that bind to proteins. This is what makes sainfoin bloat-free and and also bird's foot trefoil. They're known to increase the bypass protein in those two species. They form complexes with proteins at a pH range of 3 to 7. They also reduce the bloat potential for fresh forage. On the other hand, they're not a good way to add tannins to the forage as we're feeding it. So again, we want to cut early to have a high protein level. If we, it is important to recognize though that with advancing plant maturity, that we'll get more true plant protein, and that because the cell wall becomes more lignified, the alfalfa will have less protein. So I just put this up as a point to recognize that we shouldn't cut alfalfa earlier than what we need it. Bud stage for dairy cattle, we usually talk about first flower to 25% flower for growing animals. When we go to the later stages, we'll have more yield, but we'll also have more bypass protein alfalfa, and that is clearly beneficial to those animals. Now, some things that have been tried to increase the bypass protein in alfalfa, one is to heat it, kind of stimulating the mallard products that occur. In one study where they heated to 100 degrees for 2 minutes before instilling, they did reduce protease activity in the sample by 34%, and they increased the amino acid reaching the small intestine by 42. There's been some work on using heat to dry forage, and we've never really looked at how this affects bypass protein, but it is likely to be a positive effect on the bypass protein content of the alfalfa if it is heat dried. The problem is that heating is costly, and we have to be careful about how much heating we have. The study up above at 100 degrees for 2 minutes had minimal effect on feeding value, but greater heating can reduce the feeding value. If you remember, because we get more mallard product, because we tie up the protein tighter, and the non-fibrous carbohydrate declines to a greater extent. So again, a little heating may be good, too much is a problem. Some people have experimented with adding tannins to forage when ensiling. Again, they're naturally occurring compounds. They increase the bypass protein. However, we have to be careful because a little might be good, but too much can reduce the organic matter digestibility and may even make the forage unpalatable, reducing voluntary intake. One study added tannin, and the tannin reduced organic matter digestibility by 5.1%. However, tannin has been shown to improve silage quality in round bale silages, particularly reducing ammonia and non-protein nitrogen. So let me just sum up quickly. Treatments of either heating or tannin to alfalfa hay and silage have generally not proven cost effective. And this is especially true when we're considering the associated effect of lost energy. So what can we do? Well, the first thing is, as we said earlier, to recognize that protein level in first to mid flower is adequate to meet the dietary needs of most growing animals. We might go to the bud stage for dairy, but always go to the later maturity you can to get the highest yield and the greatest amount of bypass protein. We can maximize total protein content by minimizing leaf loss during growth. And this can be by growing disease resistance plants and in some cases using fungicide. And then, as I said earlier, and we'll talk more later on, manage to harvest carefully. I think most of us have no idea the extent of the leaf loss that we've been having when we harvest alfalfa. Now for ensiled forage, I did mention that tannin can help with baleage, but it is also important to recognize that adding an inoculant can help with ensiling. The reason that an inoculant, Lactobacillus plantarum, helps ensile forage is that we speed up the initial fermentation. We get it going faster because we're adding more bacteria, so the proteases have less time to break down the protein. We also direct the fermentation in the way that we want to produce the acids, to cause it to occur in a way that minimizes the activity of proteases and allows us to keep as much of the bypass protein as was originally in the forage. Now let's talk about some of the future, because I think that there is a great future available for us. Alfalfa naturally produces tannins in the seed coat, but not in the leaves and stems. So this means that the genes are present in the plant for tannin production, but not turned on in the leaves and stems. And one effort has been to attempt to modify the alfalfa genes so that the tannin production genes are turned on in the leaves. If we could get a little bit of tannin in the leaves, we could increase the bypass protein. Another effort has been to attempt to move genes from red clover to alfalfa. Since silage fermentation does not break down red clover protein to the same extent as alfalfa, red clover has more undegradable protein. If we could get that system from red clover into alfalfa, we could have more bypass protein in the alfalfa. This is not a tannin compound. A red clover contains polyphenol oxidase enzymes that inhibit protein breakdown. That sounds like a big fancy word, but this is the same enzyme that causes apple slices to turn brown when they're exposed to the air. So if we could put the gene into alfalfa to produce the polyphenol oxidase and then provide the energy for it, we could inhibit the breakdown of protein and again have a higher percentage of the alfalfa protein to be bypass protein. The third approach is to move tannin production genes from other legumes into alfalfa. And there's been a lot of work from different clovers and other forage crops. This has been done, but the tricky part is to get the right amount of tannin production. The concept is that a little is good. It'll give us some reduced rumen degradation, but too much will cause the forage to be less digestible and less palatable, reducing intake. And I just mentioned this happened years ago when I was back in Texas. They developed a bird-resistant sorghum. You can see the grain heads at the top for those of you that haven't grown sorghum. And the problem was always birds eating that grain. Well, the concept was to put tannin-producing genes into the sorghum from wild types, and it worked. But the first generation material reduced bird feeding, but cattle wouldn't eat it either. So they had to come back with a second round that had less tannin, sufficient for the bird resistance, but low enough not to reduce the cattle consumption. And that's kind of the situation that we're in, trying to put tannins into alfalfa. We want a little, we want the right kind, but too much can be a problem for us. The other advantage of tannins is that rapid and excessive ruminal degradation of fresh alfalfa can cause bloat, and in severe cases, death. And as I said earlier, tannin-containing forages tend to have reduced bloat potential. In fact, there was a little bit of work in Canada with some conventional breeding that produced an alfalfa line that had reduced bloat potential, but I think was not significant enough to really be a marketable product. But at any rate, if we get tannins into alfalfa, in addition to having more bypass protein for high-performing animals, we should be able to use it easier in grazing systems with less fear of bloat. So in summary, alfalfa is already a valuable forage because of its high protein content, its low cell wall, and high energy content. I think we also don't pay enough attention to the buffering capacity of alfalfa, which can be a problem when we have a lot of corn silage and concentrate. And then with the continued effort to improve it, the future looks bright. So alfalfa is high protein. We should take advantage of it. We need to recognize that the protein is highly rumen degradable. And if we really want to use it for dairy cattle, we need to harvest that forage and maintain it in a way to maximize the bypass protein in that forage. And with that, I'm done.
All righty. Hey, thank you so very much, Dr. Undersander. And now let's get to some questions. We already had a few that came across on the chat box while you were talking, which is great, folks. And be sure to type your questions into the chat box. You just simply click on the button at the bottom of your Zoom screen that says chat and type them in the box that pops up. So first off, let's talk about what exactly is the optional RFV range in feeding beef versus feeding dairy cattle?
Yeah, what we have seen is we do recommend a relative forage quality of 150 or higher for milking dairy cows. Towards the last third of their lactation, we can fall a bit below that. For our growing animals, we want something around 125 relative forage quality. And then for dry cows, something around 100 to 110 relative forage quality.
Okay. We have a question here. Is proper swathing management just as effective or close to being as effective as some other products or other varieties that are out there?
So yes, the first thing is a lot of us make a mistake and put our hay into a windrow instead of a wide swath, and we should be using that sunlight that's free to dry the hay. It'll dry faster, we can get it up off the field faster, and we can come back with irrigation. So yes, a wide swath works on all types of alfalfa.
Okay. So we've got such bitterly cold going on right now. And we know from yesterday or day before yesterday's presentations that, some hay stocks are a little tight. We've seen that prices for even corn stalks are getting high. And so now might be a good time for some folks to rethink some of their pricing as far as their alfalfa. Do you see that there might be some opportunities in this cold for some growers to maybe capture some value, especially if they have some good protein hay still left in the barns?
Certainly, and there's two considerations. One is higher energy forage is particularly important in cold weather like we're having. And then the second thing, yes, is really economically valuable to the farmer to inventory their feeds, to know which lots of feed have higher energy, higher protein, and then to work with the nutritionist to feed those forages in a way to get the most return.
Okay. I'm so glad to hear early on that you talked about how the price of soybean meal has really gone up. And as we know, alfalfa is a great alternative for that. So you might expand a little bit on that for some of the folks that joined us a little bit later towards the middle of your presentation.
Sure. So the situation right now is that soybean meal has just gone through the ceiling in price. The price is generally over $500 a ton. I've seen some as high as $560 or $570. And protein, it is a bypass protein source, but it is a source that needs to be used, but is very expensive. To the extent that we can feed alfalfa, remember only a portion of the protein needs to be bypass protein, then we can reduce the amount of total protein need in that ration and the expense. And alfalfa hay is a lot cheaper than $570 a ton soybean meal.
Well, maybe we can make it a little bit less, or maybe we can capture some more of that value at this point in time, working with our customers, of course. You know, we're in the middle of this cold stress. We've talked about drought the day before yesterday in our previous conversations here on Alfalfa U. We're likely to see maybe some more drought coming up, and so that may stress our dairy cows or our beef cattle as well. What do those cows need in times of stress, and how can alfalfa help them?
As we're thinking about drought, it is important to recognize that cattle, frankly, have the same energy and protein needs depending on their category, whether we're maintaining a cow or want a high-producing milking cow. And so while the yield will go down with drought-stressed alfalfa, as I said in the presentation, the stem percentage will decline. So what we'll tend to get is a higher than average crude protein in the alfalfa, and actually a bit more bypass protein than we would if we had full irrigation on that alfalfa. So in all cases, have the forage tested, consider the quality, and work with the nutritionist to try to maximize the performance of the animals that you're feeding that forage to.
Okay. So we do have a question here from the chat box. And remember, folks, add your questions to the chat. We've got a few more minutes here to get around to those. Let's talk about palatability of alfalfa, organic versus conventional versus GMO. Is there any difference in the research that you've seen?
No, and we actually have looked at this. There are significant differences due to the growing environment and due to the maturity, but we have not seen differences in palate and, of course, insect infestations and things like that, and diseases. But among healthy alfalfa varieties, we have not seen the differences in palatability. Now, we have seen this with the grasses. Orchard grass varieties differ considerably in palatability, but we have not seen that with alfalfa.
You know, we've got Steve Norberg will be coming up on the March 4th Alfalfa U. And folks, by the way, if you haven't already, remember, if you're registered for Alfalfa U, you'll get the links to the next two sessions as well. And you'll be able to see all the recordings on Alfalfa U's on our website there. But we'll have Steve Norberg coming up on March 4th talking about genetic advancements in breeding alfalfa and what those might mean for alfalfa growers as far as putting more dollars back in their pockets. You touched a little bit on this in your presentation, but as somebody that's got a long history in the industry, what would you like to see an alfalfa breeder really focus on and that you're excited about as far as upcoming genetic advancements?
Well, I think we're on the horizon of a lot of exciting advancements. The efforts in salt tolerance are really worthwhile because that's a big problem across the West and around the world in irrigated alfalfa. I think we're going to start seeing some yield advancements. One of the reasons we haven't seen yield increases in alfalfa as we have seen in corn is that we keep harvesting the alfalfa earlier, and the earlier we harvest it, we get higher quality, but the cost is the extra yield. And I think we're going to start to see some processes come out that will give us higher yield with the quality that we want to have. And then, of course, I think the next big thing on the horizon will be this bypass protein. If Soybean Association doesn't want to see it, but if we get good bypass protein in alfalfa, we won't need to feed soybean meal, which would be a big cost savings to many farmers.
Very, very interesting. I always just get so excited about The questions that you all answer with your work, it's just delightful. We've got a question from the audience. You talked about leaf loss. Do you have a ratio of how much loss from harvest at 35 DM to 40 DM?
We'll talk about that in the next session.
And that leads me to my next question. You'll be joining us as well on March 4th. And might you give us a little bit of a preview of what you'll be talking about then?
Well, we've done a lot of work lately. Frankly, I think many growers have been oblivious to how much leaves they're losing. Remember, the leaves are about 30% protein, the stems are 6%. When we cut alfalfa, we should be about half leaves and half stem, and there's a lot of alfalfa that's only 1/3 leaves and 2/3 stems. And not only are we losing quality, but we're losing yield in that harvesting process. And that's what I'll be talking about.
Well, I can't wait. And as somebody that ran a hay rake for my dad for quite some time, I can tell you going slow is much easier, makes him a happier man than than anything else. Well, thank you so very much for joining us, Dr. Undersander. And folks, remember, he'll be joining us again March 4th. And remember, if you're a registered attendee, you'll get those links in your email box. Dr. Undersander, thank you so much for joining us today, sir.
You're very welcome, and I wish everyone in the audience a good summer.
Well, hey, everybody, welcome back to our second half of High Plains Journal's Alfalfa U. And for those of you just joining us, my name is Jennifer Latsky. I'm the Associate Editor of High Plains Journal, and I'll be your moderator for this second session of High Plains Journal's virtual Alfalfa U. Now, in this second part of our session, we're going to hear from Mike Brook of Kansas State University, who will share some cutting-edge research into the effects of pre-cutting round hay bales during baling and that effect on forage quality and processing time. And finally, we will wrap up today with Casey France, Agronomy and Account Support with Ward Laboratories Incorporated, with her presentation on why alfalfa may just be the solution for our marginalized soils. Now, by the way, we know that there's a lot of you on the line who are joining us from your homes with your families watching as well. And next week is National FFA Week, and High Plains Journal is so proud of all of our commitment to the next generation of farmers and ranchers. And that's why now, through April 30th, High Plains Journal will donate 25% of all subscription revenue to a state FFA organization of your choice. Visit hpjsubscribe.com/FFA now through April 30th to help the FFA members in your local communities. And by the way, you want to mark your calendars for our future U events coming live and in person. We'll feature more alfalfa content at our new Farmer U in August. Watch High Plains Journal for details and upcoming calendars. You know, we couldn't do events like this, whether in person or online, without the tremendous support of our sponsor partners. And we want to thank our premier sponsors today, Alforex and John Deere, as well as our associate sponsors for this session, STAHELIWEST, American Ag Credit, and Ward Laboratories Incorporated. Now, I'm sure many of you have had some experience with the Zoom webinar platform, but for those of you who are just joining us and may be unfamiliar with how we're going to make this work, a few notes. First, we've muted your video and your microphones, and we ask that you keep those muted. To ask questions, simply type them in the chat box that appears on your screen when you click on the chat button. We've built in plenty of time, and we'll get to those in a Q&A section after each speaker. All of these sessions are being recorded, and the recordings will be posted as soon as possible at hpj.com/alfalfau. And if you're a registered attendee, you'll be emailed a notification when those recordings are up. The schedule of all of our series of sessions and speakers is there as well. Now, before we get started with our first speaker, here's a word from our sponsor, John Deere.
Now you can get more from your mower conditioner with John Deere 0 Series mower conditioners. Cover up to 10% more acres per hour with the wider cutting width of the C500. This lets you hit tight harvest windows and increase your productivity. The John Deere 0 Series mower conditioners feature side pull and center pivot models with a wide range of cutting widths to meet your needs. Mow with a wider range of tractors and handle hills easier. Use less horsepower and fuel thanks to the lighter weight of the redesigned C400. Customize your windrows to improve dry down thanks to wider conditioning rolls. Width of the windrow is critical to dry down, and the C400 lets you put down windrows of up to 133 inches wide. Many John Deere 0 Series models give you the ability for wider windrows thanks to the forming vanes. This lets you preserve hay quality while giving you more time to bale before Mother Nature strikes. In addition to quicker dry down times, you'll speed up knife replacement. With quick change knives, you can cut time changing knives in half. With a simple tool, you're able to change your knives out in minutes and return to cutting, helping you maintain the best cut quality. You'll also get more choice when it comes to conditioning your crop. The wide variety of models in the 0 Series let you match the conditioning options to best fit your crop and operation. For grasses and grass legume mixes, our economic impeller options fit the bill. The urethane roll is excellent for thicker stem grasses, cane, or legume crops. Two steel intermeshing options, the V10 and the Trilobe, offer durability with improved crop conditioning. John Deere is confident in the durability of its mower conditioners. To ensure you share this confidence, we've upped our warranty. Now, both parts and labor are covered for all components on the proven low-profile cutter bar for 5 years on all John Deere mower conditioners. Get more productivity, tractor compatibility, uptime, choices, and confidence with John Deere 0 Series mower conditioners.
Well, thank you so very much for that message, John Deere. And later on in this session, we'll hear from our other premier sponsor, Alforex Seeds. Remember, you'll be able to find more information about all of our sponsors and the services and products they provide in your registration packet and materials that were emailed to you later this week. And you can always find more information online at hpj.com/alfalfau. Well, now it's time to get started back with our speaker, Dr. Mike Brook. Mike Brook is a professor in the Department of Animal Sciences and Industry at Kansas State University and has a career that spans academia and allied industry. From a crop farm in central Missouri to studying the effects of dairy processing plant solids on forage crops at the University of Missouri-Columbia, to a career as a livestock production specialist for Land O'Lakes in southwest Minnesota, and finally, his 23-year career at Kansas State University, Dr. Brook has spent a lifetime helping dairy farmers improve their dairy cattle nutrition, forage quality, heat abatement, and facility design. Today, Dr. Brook will share how pre-cutting alfalfa hay at baling affects forage quality and the efficiency at forage processing time. Dr. Brook, welcome. It's a pleasure to have you at Alfalfa U. The screen is all yours, sir.
All right. Appreciate the opportunity to participate in the meeting today, and appreciate everybody in attendance as we talk a little bit about a study that we did finished up about a year ago now. The actual harvesting was done prior to that, but just wanted to share. We shared a little bit about this last year, and kind of want to finish up and just see what results that we had. So as we think about what we do with particularly round bales of alfalfa, we have to process those before we actually mix those into a TMR, or a ration for dairy cattle or beef cattle even. And there are some different options that we can use to do that. There are some new models of balers out there that actually slice the forage as it's actually wrapped into the bales. So one of the things that we wanted to look at in this study is, can we eliminate the need for the tub grinding step and the losses that are associated with that? And in doing this, we also wanted to monitor to see if we were having any impacts, positive or negative, on the forage quality of the material that we were baling. So in this particular study, We worked with 4 farms in southeast Nebraska, and these were actually beef farms, not dairy farms. And we worked with John Deere on this project, and we do appreciate their support. One of their dealers in the area really helped us a lot in getting equipment around to different farms to work with. So we actually used the exact same baler on all 4 farms. It was moved from farm to farm, so we had the exact same baler, and it was a John Deere 560M. It was the mega wide HC squared series, and the blades in there were set so that they slice the forage every 6 inches. So we did a study where we baled the forage and did replications on each of the farms. So we had 6 bales that were sliced and 6 bales that were unsliced. The way we accomplished that is we would bale an unsliced bale first, stop, kick that bale out, set the knives in, and then bale a sliced bale. So as we went down across the field through the windrows, we were alternating the bales sliced or unsliced as we did that. And so anyway, we would produce a total of 12 bales per farm. Those were stored for about 5 to 6 months prior to removing them from storage and continuing with processing that I'll explain a little bit later. So at baling, we obtained weights. We had a scale that we constructed so we could actually obtain accurate weights of each bale in the field. We also did some measurements to look at length and diameter, and then we took forage quality samples. And the way we did this is we actually took a sample from the outer 6 inches of the circumference of the bale, and then we went in inner 6 to 18 inches. So for our forage quality analysis, we actually did look at the outer layer versus inner layer. And we also did that after 5 to 6 months of storage. So we reweighed the bales, we did all the dimension measurements, and then we did core samples, and again divided those into the outer 6 inches and then 6 to 18 inches inside. So we present the data. Some of this data is combined, some of it's not, but we'll evaluate that. So initially, as we looked at bale weights at baling, the bales that were produced with the knives cutting actually weighed more and significantly more than those that had just the knives backed out, so just normal baling. So the only setting that changed on the baler between cut and normal was just simply moving the knives back out of the way so they did not touch the forage. So all of the tensions and everything remained the same between the normal and the cut bales. So as we slice that, you can imagine we're making a smaller particle size. We can probably get an increase in the amount of material that we can get in that same size bale with those same settings. And that's really what we saw as we look at density. The density of the cut bales was greater than normal or the uncut bales. So indicating that as we reduce that particle size within the baler with the cutting action of the knives, we were able to pack more material into each of those bales. So if you're thinking about, efficiencies, might be an opportunity to gain a little bit of efficiency here because we're packing more material into a single bale, so we have fewer bales to move off the field. Now, I guess an argument to this would be that, well, you could have changed the settings on the normal bales so that you increase tensions and stuff so that you could pack more material in there. And that is true. We could have done that. But again, for the purposes of the study, we really wanted to understand better what was the effect of slicing that material versus not slicing material during the baling process. So that's the reason we chose not to change other settings on the bale. As we looked at baling rate, we actually did a little bit of time and motion study here where we actually kept track of start to finish in the baling process of each of the bales on each of the farms. So we were able to compare then the actual baling rate, or the rate at which we produce bales. And between the cut and the normal bales, there was no difference in the amount of dry matter per minute that we were able to pack into the bales. So I think the take home here is that using the cut option does not slow down the baling process. So sometimes we have some concerns possibly as we add these types of processing to something like baling. Are we actually slowing down the baling process? And I think we can really share from our data that did not occur. And we were able to maintain a similar bale rate as to normal bales. Now, one of the things that we did, and again, this is combined data, so this is both the inner and the outer core samples averaged together. And one of the things that we did see in this study, and again, this is immediately after baling, we did see a slight change in NDF and ADF contents in these, and also in lignin, but lignin would go along with the ADF, so that's not unusual that we'd see that. You can see that the air bars are really, really close together here on these averages, so actually had a really, really tight data set, and all the samples were analyzed through the same lab, so we kind of removed the possible interference from lab variation. So all of these samples were processed through this same lab at the same time, actually. So helps remove some of those noise factors that we sometimes get into studies. So a very slight increase in the fiber content when we use the cut treatment to bale. Not sure exactly what this is associated with as far as what thing were we losing. It's possible that there was some issues with leaf loss, although that wasn't noticeable on the ground because we did look on the ground after the baling process to see if there was, a visible difference there, and there was not. I have a bit of a concern when we think about the hay probes that we use to take these samples. If we have a smaller particle size in those cut bales, which we did, as you push that probe down through there could be some separation that's going on in sampling that could have resulted in this difference that we see here. Again, this is these are very, very small differences. They were significant. But are you going to be able to actually see that in a feeding situation, animal performance? I really don't think probably we can. So just kind of keep that in mind that this could be a sampling issue as opposed to an actual leaf loss situation with baling with the cut setting. One of the interesting things is that NDF digestibility did not differ. So if we were having a slight effect on fiber levels with the cut treatment, it was not having an impact on the digestibility at 240 hours. So I think from a fiber utilization standpoint, I think this is pretty important that we did not negatively impact that with the cut treatment. So as I said, these bales were stored outside for 5 to 6 months. And then we came back and repeated measurements. So here's just one of the farms and the bales that have been hauled up for us to evaluate further. And so in this next series of slides, we're going to talk about not only the shrink and things that we saw during that 5 to 6 months of storage, but also we'll talk about the processing and how that was impacted by the fact that some of these bales were cut. So when we look at shrink, and this was not significant, but it was a trend at any rate. Shrink was less for the cut bales. So if that was due to the fact that we had a higher density, with those bales. Again, the bales were all stored similarly at each farm. So these bales were stored outside. And again, for the 5 to 6 months, the control bales or the normal cut bales were stored right next to the cut bales. So everything, conditions for storage would have been the same on each individual farm for both of the treatments. So our cut bales, at least numerically, seem to have less shrink during that storage period. Another thing that we looked at is the fiber level. So again, remember we sampled after storage. Before we put these bales through the processing, we sampled the outer 6 inches and then inside from 6 to 18 inches. So if you see inner, outer, the outer refers to the outside 6 inches of the bale, and the inner refers to the next 6 to 18 inches in the bale. And here we've got kind of things all put together. We've got the beginning numbers as well as after storage. So the beginning numbers would be reflective of values that we saw at baling. So those are the blue bars, and then the reddish bars would be after the 5 to 6 months of storage. So let's talk about ADF first. You can see that over time during storage that the ADF content increased slightly, and that would be expected. These bales were stored outside, so they weren't protected from weather. You can see that we had a greater impact on the outer layer than we did the inner layers. Again, when we look at loss of nutrients or changes in forage quality in round bales stored outside, much greater impact on the outer layer than inside the bale, but still from our study, a bit of increase in fiber level as you actually went down deeper into those bales. Same situation with the lignin content over on the right of your screen. Again, increased slightly with storage. So loss of some of those soluble nutrients and stuff associated with the leaching effect of moisture on these bales, obviously. So again, nothing surprising here, but we did see an increase in the fiber content, and that was similar across treatments. So I want to now switch and talk a little bit about what we saw after we processed these bales. So the bales that were baled normally, the uncut bales, were put through a tub grinder. That's what this picture depicts. So we put each individual bale through a tub grinder. We actually tracked the time it took to process each individual bale. Right out of the tub grinder, it was the material was dumped into a TMR wagon, and so that we could weigh the material. So we weighed the bales before they were dropped into the grinder, and then we weighed the material that actually made it into the feed wagon. And there's always a little bit of leftover material in those grinders, and we accounted for that as well. So that was all accounted for each individual bale at each of the farms. The cut bales were placed directly into the TMR mixer, okay? So our normal bales had to go through a grinding process. Our cut bales did not go through a grinding process. They went directly into the TMR mixer and were processed by the TMR mixer. So we've got two different types of processing here. And so there's a little bit of confounding, I guess, of the data, but just keep in mind we're trying to depict what would happen if we baled these bales with a normal situation and we had to grind them before we could feed them to animals, versus if we use the cut treatment during the baling process, we can go directly into the TMR wagon and save some loss possibly by doing that. So after we had the bales either ground and dumped into the TMR wagon, we laid the material out in windrows, whether it be the normal bale processing with the tub grinder or the pre-cut bales going through the mixer wagon. So we'd lay out these windrows of material. Then we would go down through these windrows and obtain samples for further analysis. So the TMR wagon did have a scale on it, so we were getting accurate weights of the material deposited into the TMR wagon from the grinder or the bale that we processed that was already cut through that. So just kind of how we laid it out. We repeated this process exactly the same on each of the farms that we dealt with. So we look at dry matter losses then, okay? So the amount of dry matter that we recovered was greater when we used the cut bales going directly into the TMR wagon, as opposed to taking uncut bales the normal way that we would bale and running it through a tub grinder. So very significant difference in loss here. The cut directly mixed, we get less than 2% loss in that process, where if we take it through the tub grinder, looking at about an 8% loss in dry matter just in that process. Now, here's what I want you to think about. And as we talk about particle size here in a minute, this will start to make a little more sense to us. This is just the loss that we experience going through the processing, okay? So the measurements and dry matter loss here are basically just what occurred during processing. If you think about what you normally do on a farm, you bring a tub grinder in and you might grind up enough material for a week or 2 weeks or even longer, and it sits there in a pile exposed to the weather generally. Sometimes it's under roof, but many times not, just out in the open. So these losses there would be on top of this. So this 8% is just what you lose when you go through the grinding process, and does not include anything that occurs as you try to store that ground material for a longer period of time. When you look at the actual pounds here, looking at about 75 pounds of loss if you look at the normal bale and grind situation, versus about 20% if you're, or excuse me, about 20 pounds if you're looking at the bales that were cut and then processed directly through the TMR wagon. So if you think about this, this might be about $8 a bale difference in retained forage. And if you look at how we did that, we put a value of $20 a ton on the alfalfa hay. And maybe that should be higher under today's markets, but for where we're at the time and where we've been much of the time here in the last year or so, that would catch a lot of it. And then we looked at the value of the crude protein, and assuming that we're losing probably a higher percentage of leaves in this grinding process, this is how we came up with the numbers we used to assess whether or not, or the amount of loss that we might have, and putting a value to that. So it does appear that the use of the cut procedure and then going into the TMR directly could reduce our losses about $8 a bale. So very significant depending on the size of the livestock operation that we might be looking at. Now, one of the things to consider, tub grinders obviously are designed to grind things very quickly, and they do. And when you dump those cut bales directly into a TMR wagon and process them that way, it is going to take a little longer than what it would to process a bale through a tub grinder. So in our study, it took a little less than 4 minutes per bale to process each of the bales through the tub grinder, where if we ran it through the cut bale through the TMR mixer, that would be about 11 minutes. Now, one of the things we weren't able to assess in this particular study is what if you took a normal or an uncut bale and tried to process it directly through the TMR wagon, like we did with cut bales. My observation, based on some other things that I've looked at with other producers, is when we take an uncut bale, throw it into the TMR wagon, and try to process it there, it's going to take a lot longer than 11 minutes per bale as it was with the cut. So I do think you save some time if you're processing bales through uncut bales through your TMR wagon. If you would use the cut function on this particular baler, I think you would significantly cut down your processing time through the TMR wagon. Okay. Now, I mentioned before that we saw an increase in fiber right after baling between the normal bales and the cut bales. And as we analyze those windrows that we get from after processing, we've also found that we saw this slight increase in ADF and NDF as well as lignin with the cut bales. But again, keep in mind, these are really, really small air bars. The net effect, if you look at the percents there, is actually really small. It is significant. And again, this is something that we saw right after baling. So I think this is just an effect of that continuing to follow through in this particular study. And not when we look at animal performance differences between these numbers, it's very, very, very small. So I really don't think on a farm basis we'd actually be able to detect the difference when feeding this type of material to animals on the farm. I want to talk about another interesting thing that we found in this study, and I do think this is quite significant. Okay, so before I do that, I want to explain exactly what we did. So what you have here in front of you is the Penn State particle size separator. So it's a series of basically 3 different screens. So this screen with the largest holes on it, those holes are basically 3 inches in diameter. So anything retained on top of that screen were particles of feed that were greater than 3/4 of an inch. Okay. The material that drops through the top screen falls onto the second screen, and that second screen, the holes in there are 5/16 of an inch in diameter. So the material that you get retained on this second screen would be that material that would be less than 3/4 of an inch in length, but greater than 5/16 of an inch in length. Okay. Then we drop down to the third level, essentially. So you've got holes in this screen. The holes in this screen are 5/16 of an inch down to 5/32 of an inch. So the holes in this screen are 5/32 of an inch. And the material you'll have here then on this third screen is that material that is less than 5/16 of an inch, but greater than 5/32. And then you have this final pan, which is, there's no screen in there. It's just the material that passed through that 5/32 screen. So the information we're looking at here in the next slide is based on this screening procedure. And this is a procedure that we typically use on dairy rations and in ground feeds to determine particle sizes and how that might affect rumination of cows. So these are actually just an example. We took samples of both the cut bales and the uncut bales that were ran through the tub grinder, and we ran this particle size separation on those. So what you're seeing on this slide is those bales that were run through the mixer and were the cut bales. That's on the left side of your screen, and on the right side of your screen would be the uncut bale that went through the bale grinder. Okay, so you can see here visually as you look at this, if you look at that the pan there at the top of the screen, so this would be the fines essentially, the very top. You can see visually a lot fewer fines here when we took the cut bale through the TMR mixer directly. And we also ended up with more fiber up here that is greater than 3/4 of an inch. So the fiber that's greater than 3/4 of the inch would be associated with increased rumination and stimulation of the cow to ruminate. The other thing I want you to think about is you think about these ground bales that sit out there in the open, that pile, however long it is between the times you have the grinder come to your farm. You've got a lot more fines in that material. This material is probably more likely to be lost, blown away, impacted by rain than what we would have if we were thinking about what you see on the left side of the screen. So how do the actual numbers look? Well, you can see that with the cut bales, we retain a lot more material, actually about 35% of the material versus about 15% is actually retained on that top screen. So about 35% of your particles are greater than 3/4 of an inch. And again, if you're looking for things to stimulate rumination, that's really what you want. If you look over here to the far right, you've got the amount retained in the pan, okay, or the fines. So about 50% of the total weight was of the uncut bales that were run through the tub grinder was actually in the fines, as opposed to only about 31% for the cut bales running through the directly through the TMR wagon. So bottom line, how do I look at this? Well, what I tell you is when you take the cut bale and you put it through the TMR mixer, at least what we found in our situation here is we had a much greater percentage of the material would be greater than 3/4 of an inch, and much less would be in the pan or very fine. Also differences on what was retained on top of screen 2 and screen 3. And again, longer particles for the cut bales as opposed to the normal bales going through the grinder. So I think something depending on why we're processing and what we actually want to elicit in the animal by feeding forage, something for us to really consider, particularly for dairy producers probably. So in conclusion, our pre-cut bales, we saw an increase in bale size and density. There was some small increases in fiber concentration in those pre-cut bales. As we look at the last part of the study where we actually process these bales as we might normally do on a farm, we can see that if we put the pre-cut bale into the mixer wagon directly, as opposed to running bales through the grinder, there's going to be an increase in processing time, probably less though than trying to put an uncut bale into the TMR wagon and process it that way. We saw the reduction in shrink by eliminating essentially the hay grinder from the situation and doing that in the TMR wagon. Again, as I mentioned before, we did continue to see that slight increase in fiber content. I really think that may have really been associated with the sampling issue as opposed to an actual issue induced onto the situation by the baler. So kind of our next steps, or how do we see this maybe moving down the road? We probably need to go back and try to assess why we saw this slight increase in fiber content. Again, while it's statistically significant, is an animal, are you going to be able to detect differences in animal performance when feeding hays produced from the cutting during the baling process? I really don't think from our data that we could be confident in saying that there'd be differences there. So just want to say thanks. Billy Brown was the graduate student involved in this project as part of his PhD thesis, and really appreciate all his work on the process. We also had 3 gentlemen there associated with John Deere, and that helped with some of the arrangements as well as some of the actual work, data collection, Dr. Ball is our statistician, and Dr. Bradford was one of my colleagues here at K-State that was also involved with the project. Also want to thank those cooperating farms in Nebraska for allowing us to come on their farms and do this research, as well as support that was provided by John Deere, both in making arrangements and getting equipment around, as well as financial support for the forage analysis and travel associated with this particular study. And with that, I just wanted to share, this is the Flint Hills, just south of Manhattan. And it's not taken today, obviously, but I'm looking forward to days when we can enjoy a nice sunrise or sunset over the green fields once we get to spring. So thank you for your participation today, and I guess we're ready for questions.
All righty. Well, thank you so much, Dr. Brook, for your great and valuable information. I learned so much. I was a beef cattle girl, and I learned so much about dairy cows from you every time we're together in a room. So let's get to your questions. Remember, folks, if you've got questions, and we love those, that's why we're putting on these events, click on the chat button at the bottom of your Zoom screen and type those in the box that pops up. We've got one from one of our viewers here who is in southern Idaho. And
Okay.
he says there are some growers putting up hay in round bales, but mostly large squares are dominant in the 3x4 and 4x4 configures. Has there been any comparison between round versus square as far as in this research?
So to my knowledge, the pre-cutters are only available on the round bale machines. They're not available on the square bale machines.
Okay, maybe that's an opportunity for somebody out there to jump on.
Yeah, I don't, there may be some challenges if you put this in. So in a round bale, the way this works, those knives actually pull back for the outer wrap or two to hold the bale, help hold the bale together. And with a round baler, you could see that those bales were also net wrapped, not string tied, which with the cut function, that would be the way we'd recommend doing that, is to use net wrap to help hold those together. I think with the square bales, we'd have to look at probably something other than string tying if we were going to pre-cut, just to hold things together.
So that leads me to my next question, because I was trying to visualize this in my head. And do we see a lot of loss in the field or in storage out of those bales in the pre-cut bales? Do we leave anything behind? Is there anything that we can do? You touched a little bit on that in your presentation, but for those of us that joined a little bit later, is there anything that we need to be aware of as far as what we're leaving on the ground?
Well, we didn't do any measurements. I wish we had. Initially, when we put this study together, we had talked about doing that, but because of logistics, we're not able to do that. But we did visually look behind the baler for each of these treatments, and we didn't notice any visual difference on what we saw being left on the ground. So this hay was a little more mature. If you looked at the protein content, it was a little under 20%. So it wouldn't be maybe what we'd call classified as dairy quality hay. But again, these were farms that had beef herds, not dairy herds. So little difference in what these producers wanted to actually harvest to feed to their animals. So.
Okay. We got a question. How did this research all come about? Was there just a topic or a problem or an idea that you guys came about to try to solve?
So I guess this was one of those projects that sometimes you get a call, and I got a call from John Deere, and they had some questions about whether or not we'd ever looked at this. And then I took that question, sat down with Billy, and said, okay, this is kind of what they want to get out of this. And he and I took that a little bit deeper then. We wanted to see what the effect of processing was as you got ready to feed it to the animals. So I'd say this is an example of a joint project where industry had a question they wanted to get answered in terms of their baler. And we wanted to take that a little bit further and look at how's this going to carry out as we actually utilize this forage to feed animals. So, and the storage loss part, that was another thing that we had added to that.
Okay, let's see here. I do see from a few that there are some square balers that have cutters and roto cutters. So yeah, 4 large square balers have had knives. So maybe that's something that we can look at in the future.
And what I don't know is what the spacing are on those knives. The spacing on this round baler, it actually does, they're spaced every 6 inches. And whether or not the square balers would be spaced that close together or not, I'm not sure. So
Okay. You know, one of the reasons why we've brought dairies into a focus on a day where we've got a lot of our Kansas State folks joining us is because Kansas has seen so many large dairies coming into our Western Kansas region. You know, you work with those folks. Are there some opportunities that our alfalfa growers that you can see from both sides of the fence, as it were, for alfalfa growers to really make themselves marketable as far as their products and their services to larger dairies?
So our larger dairies, by and large, are probably going to prefer to buy large square bales. The reason for that is they mix diets on the farm. That way it's easier to add just a certain amount of alfalfa to that mixer load if you're using large squares. If you're using round bales, that generally, and we do have some dairies that do that, but that generally means that they run it through a tub grinder first, or they have to run it through the TMR wagon, dump it back out on the pad, and then add back. So it's kind of an extra step for them, if you will, although they sometimes do that. So I think maybe to smaller dairies, there might be an advantage for this. Our large dairies, I think probably just due to their feeding systems are going to continue to probably want to purchase the large square bales.
Okay.
For, a lot of our large dairies also, they purchase this hay ahead and actually put it in storage. So when you think about stacking square bales versus round bales in storage, you're going to get a lot more tonnage in your storage facility with square bales. Probably easier to handle too.
Oh, yeah, for sure. Well, now we've got a question here, and I think you talked a little bit about this, but maybe expand it on again. Remember, we've got folks that are joining us mid presentation. Let's talk about the premiums paid for cut bales. You talked a little bit about how we've got better protein availability. We're doing more of the work for the customer, so there is a benefit, right, for both sides.
Yeah, so I'm not aware that anybody at this point is actually paying more for those cut bales. Although what I would encourage, if you're a custom operator and you have a baler that has this capability, I would encourage you to share the differences in dry matter losses. So if you're dealing with a customer that is going to be baling round bales, and then they're going to take those round bales through a grinder, we know that from our research, just based on our research, that there's going to be a significant difference in dry matter loss, and that really amounts to about 52 pounds per bale.
Okay.
So if you can use the cut function and run it straight through a TMR mixer as opposed to running it through the grinder. I have no idea when you grind this hay and let it sit outside in a pile for a week, 2 weeks, 3 weeks in between grindings, your loss there based on some other things I've done is probably anywhere from maybe 10 to 20% of the dry matter. It just depends on how much additional rain you get on it.
Okay. Or out here in Western Kansas, how much wind?
Exactly. So, you've got those issues that you have to deal with that we didn't account for in this study. So I do think there should be some premium here, but I'm unaware that at this point that anybody's been willing to pay for that. So,
okay.
From the custom harvester perspective, we did not measure it in this study, but probably you're using a little more horsepower to do the cutting. We didn't see a difference in baling rate. So baling rate was the same, but the question would be, are you going to use just a little bit more fuel to do this? And you would assume that would be the case. So,
okay. We did have a question at the top. Were there comparisons done to stationary slicers versus what we've got here?
No, we did not in this study, no.
Okay. Let's see here. We talked a little bit about, we talked about the digestibility, but is there a change in palatability of the pre-cut hay?
We did not assess that. And I guess one of the, questions for the future. So if you would have taken this pre-cut hay and if you would have put it into, say, a bale feeder,
mm-hmm.
versus long hay, is there a difference in wastage? Is there a difference in palatability? I think that would be an interesting thing to assess. My assumption would be, based on what we know about reducing particle size of feed, that the cut bale would be more palatable and have less wastage than just the round bale dumped into the feeder.
Well, folks, it looks like we've gotten through all of your questions here today. Any final thoughts, Dr. Brook?
No, just appreciate the opportunity to share this morning, and hope everybody's staying safe, and hopefully we're to a little warmer weather here in a couple of days for most folks.
Amen to that. I can't imagine what those dairy cattlemen are doing right now. So bless their hearts, and let's hope we can get through all of this with some minimal, challenges out there in our dairies. So thank you so very much for joining us, Dr. Brook. We'll talk to you later, okay?
All right. Thank you, guys. Have a great.
Well, now, while we get our next speakers lined up, we want to take a brief moment to recognize some of our sponsors for today's session. And coming back to the screen is Doug Bastian, North America Sales Leader with Alforex Seeds. Doug, thank you for joining us again today. We've had some tremendous speakers already, haven't we?
Yes, we have. And as Alforex Seeds is a very proud sponsor for Alfalfa U, and we look forward to its continued success. I really hope you've picked up a lot of information here this morning, and that you can continue to learn through the next series on March 4th and also on March 11th. So with that, I'll turn it to you, and we look forward to the continued success of Alfalfa U.
Alforex Seeds prides itself in having over 300 distributors and dealers across the U.S. representing the Alforex and Dairyland Seed brands. Alforex Seeds, in combination with the Dairyland Seed brand that we support, we have one of the largest portfolio of products in the market today. But don't take it from me. Why don't we take a little bit of time and listen to some of our very satisfied customers and how our products performed on their farm. Again, welcome to Alfalfa University, and here, let's take a listen to some of our customers.
Mike Nielsen stated, "This is our first field of Higest and it's doing well. The first 3 crops are testing better than neighboring circles of competitive varieties. So far, we like what we see." Jake Brock shared, "We're on a 3-cut system and tonnage is big time for us. That's why we moved to AFX 469 from another Alforex variety. From the looks of this 160-acre field, we'll be getting the yield bump from this high-ton alfalfa we were looking for." Danny Joe Farms stated, "When salinity is a problem, getting a picture-perfect stand can be a concern. Not so for Danny Joe Farms, LLC at La Mesa, New Mexico. Their dealer, Scale Ag in Las Cruces, New Mexico, recommended PGI 908S for their 100-acre field that tends to be high on salinity. The field was seeded on September 23rd, and the photo was taken on October 30th. Mike Schuppe stated, "Dairyland Hyperforce 3420 consistently yields a fine-stemmed product that tests well and is a favorite among our customers."
Well, thank you so very much, Alforex Seeds. Thanks also to our other premier sponsor, John Deere, and our associate sponsors for today's session, STAHELIWEST, American Ag Credit, and Ward Laboratories Incorporated. And now it is my pleasure to bring to your screens Ryan Dennert with Ward Laboratories to introduce our final speaker of the day. Ryan, welcome to Alfalfa U. I sure hope it is a little bit warmer up there in Nebraska than it is down here in Dodge. It was 10 degrees this morning.
Well, you know, we're kind of in a heat wave right now. It's 21 degrees out here in Nebraska today. So we feel like, you know, we might be able to take our coats off, maybe not wear a stocking hat, something like that, but it certainly feels warmer than it did the last couple of days. All righty. Well, it's, as always, we're just really excited to be a part of the High Plains Journal U series. We feel there's a ton of value in these events and helping to stay in line with our vision and mission to continue to find opportunities to educate producers, not only around the Midwest, but around the globe, and continuing to do what we can to make sure that producers have the data necessary to make the decisions on their operations. And today is no different, right? We have a phenomenal speaker for you today. She's originally from Freeport, Maine. She's been raised around sustainable systems and direct to market farming. She's lived in Nebraska for about 10 years now with her husband and her 2 golden retrievers. As part of the account development and agronomy support team, Casey is enthusiastic about helping farmers address and find solutions to challenges. Casey and her husband live in Gothenburg, Nebraska. They work to make their Midwest farm more productive through incremental changes to improve their soil health. Casey received her bachelor's degree in biology from Creighton University and her master's degree in biology with a focus in molecular plant biology from the University of Nebraska at Kearney. Her thesis work was investigated the effect of salinized water on alfalfa production. So Casey knows what she's talking about, and she's going to do a great job for us today. And without further ado, I present to you Casey France.
Thanks so much, Ryan, for that introduction. I am going to share my screen. Awesome. All right. Thank you, everyone, so much for attending this session of Alfalfa U. Thank you so much to all of our sponsors. And again, Ward is very happy to partner with High Plains Journal as we put on all of these wonderful educational seminars. Today, I'm going to be speaking about why I believe alfalfa can be a solution to help mitigate marginalized soils. And specifically, I'll be speaking to salinity issues in soils as well as our water sources. So just a quick background, Ryan covered most of this. So I'm originally from Freeport, Maine. I was raised around sustainable agriculture. So the farm that I kind of grew up hanging out at is an educational farm that produces grass-fed beef, a lot of vertical farming, things like that. I was brought out to the Midwest with the dream of becoming a dentist, and I fell in love with plant biology. So I took some courses at Creighton University in plant biology and found a mentor in one of those professors who really encouraged me to seek out other opportunities in this industry. I was blessed to receive a graduate assistantship at the University of Nebraska at Kearney, where I did my thesis work. My husband and I met when we were both living in Omaha and decided to move back out to Gothenburg so we could help out at the farm. So that being said, we farm in Gothenburg, Nebraska. We do farm conventionally. We utilize strip tillage. So that's one shift we have made to be more sustainable on our operation. And in my career background, I started out working for Monsanto, Legacy Monsanto, straight out of graduate school. I was with Indigo Agriculture for 2 years as an agronomist, and then I accepted a position with the Ward Laboratories, and I've been with the team for about a year. And I just wanted to include some fun pictures. This was from a sweet corn pick at the Gothenburg Water Utilization Learning Center, now run by Bayer. Changing some water on a cornfield during the summer. Again, changing water with one of my dogs, Piper, and driving tractor because women can farm. So just a brief overview of what I will be speaking to. I want to address the difference between salt stress and salinity. Then I'll be talking about the global prevalence of salinity. Then I'll talk about different salt tolerant strategies that plants have adapted over time. Then I'll be talking about two broad categories that plants fall into, whether they're salt tolerant or intolerant. Then I'll be leading into plant defense mechanisms to lead into the overview of my salinity research, as well as how this can be applied in the field. So what is salt stress versus salinity? So soil salinity is that salt content that is present in the soil. And a lot of crops are very sensitive to salts. It's a huge agricultural problem. The dollar amount is approximately $12 billion per year due to losses of crops and ground. And then conversely, salinization is increasing the salt content in the soil. So it's that buildup of salts incrementally in our soils. And this is created through natural causes as well as management practices. So delving into salt stress a little bit deeper, this is induced through either water or soil salinity. So salts are naturally occurring in our waters, as well as soils. And these salts are prevalent through natural processes of what's known as mineral weathering, so the breakdown of minerals in our soils. as well as the artificial process of irrigation, which is a main method of getting a lot of crops started. So consequences of salt stress include reduced plant growth, which leads to reduced yield, of course, reduced water quality, as well as soil erosion, which will lead to infrastructure issues. To the right of this slide, I have an example of rice, which is a moderately tolerant crop to salinity. So on the left here, we see the tolerant variety. And on the right, of course, is a salt susceptible variety. So we see a lot of dieback, we see poor germination, where this cultivar is thriving. Next, I'll be defining soil versus water salinity. So there is a difference between the two. And these two tables are taken from one of our internal resources that you can find on our website, our ward guide. So table 63 goes through how we classify salt-affected soils based on salt saturation extracts. So the EC is going to be the electrical conductivity, and that's an estimate of total dissolved solids. So the millimoles per centimeter can also be associated with another parameter termed decisiemens per meter you might be familiar with. And then the SAR is the sodium absorption ratio, while the ESP is the exchangeable sodium percentage. So general features of saline soils are going to include having a white crust on the soil surface as those salts build up to the surface of the soil. As we know, that topsoil is very vital to good crop production. Another feature of saline soils is generally the pH is less than 8.5. So usually they're not going to be considered saline soils in an alkaline soil environment. And a couple last points, the principal cations present in a saline soil are going to be calcium and magnesium, usually lesser amounts of a sodium ion. And then there can be presence of gypsum, potentially lime. And most importantly, in the saline condition of soil, the soils remain aggregated or flocculated. Conversely, sodic soils do not have soil structure. They do not have good soil structure. They're low in salinity, but they have high amounts of sodium ions, and the soil pH can be very high, very alkaline, as high as 10. And this is due to formation of sodium carbonates in the soil because, of course, in a sodic soil, there's a lot of sodium ions present. So because of this condition, soils are physically dispersed or deflocculated, which causes reduced entry of air and water into the soil. And then another effect of sodic conditions creates excessive soil, promoting dispersion and swelling of clay minerals. And this also restricts water movement. A major effect of sodic soils is going to be sodium toxicity to crops. Really briefly, saline sodic soils have the chemical properties of saline and sodic soils. The presence of excess salt maintains the soil permeability and actually keeps the soil pH below 8.5. So we won't be in as alkaline environment in a saline sodic soil. To reclaim soils that are saline sodic generally requires leaching of the salinity and leaching of that exchangeable sodium with, for example, gypsum application before that crop growth will be improved. Briefly, I'm going to go over the salinity hazard interpretation guide. So again, this is in the electrical conductivity. So that is, the electrical conductivity is an estimate of the total dissolved solids. So irrigation water quality is dependent on the chemical composition of the irrigation water and has detrimental effects to crop production that are salt intolerant. Next, moving on to the global prevalence of salinity. So salt affected areas affect approximately 831 million hectares worldwide. And the arable land is only 7 billion hectares. And that sounds like a lot, but we're losing ground year by year. To put this into terms that are a little bit more understandable, 1 hectare is approximately 2.47 acres. So cultivated lands that are currently being farmed include 1.5 billion hectares of land. 23% of this 1.5 billion hectares are saline, while 37% are classified as sodic. And there are estimates, and there is a broad range in the estimates of 20 to 50% of irrigated lands being salt affected. So that leads to the hypothesis that there are salts present in a lot of our irrigation water. There's high variability in the amount of salinity that's present in irrigation water. This map does a really wonderful job of illustrating how this is prevalent on a global scale. So again, as I said, 21% of our cropland is under irrigation, and that comprises approximately 324 million hectares. Irrigated agriculture does comprise approximately 30% of our total agricultural production. In the United States specifically, we can see the predominant areas that are affected include California, Arizona, North Dakota, South Dakota, as well as Texas. Texas has a lot of very salty irrigation, especially as you see down here in the valley. Map is just illustrating that on a global scale, every country is affected by salinity and sodicity, as well as saline sodicity. In the United States specifically, the primary salt affected areas are going to be found in that western region. Again, those states are going to include California, Arizona, North Dakota, South Dakota, and Texas. We can see this really deep purple area down in the valley of Texas, bordering Mexico. Really terrible saline sodic problems in the upper Midwest. And then over we see in the Middle East, as well as Australia and North Africa, has significant problems. Their total area that's affected, the Middle East has 189 mega hectares that are salt affected. Australia has 169, and North Africa has 144. So this is a significant problem on a global scale. And this does have a significant effect on how our population trend is going. So through predictive modeling, they're saying by 2050, our population will rise to 9 billion. So this is problematic because there is no predicted increase in irrigated or arable land that we're able to farm. Next, I want to address salt tolerant strategies. So these are going to be mechanisms that plants have adapted in order to deal with salts in their environment. So this is just a really great diagram that illustrates the various mechanisms plants have adapted. Some of these include restricting toxic ions at the root level. This is known as exclusion. Right here we see. Another is transporting toxic ions to the stem and the leaf sheath or older leaves. This is known as compartmentation. Additionally, excretion through what are known as salt glands, salt hairs, or salt bladders. We'll get a little bit more in depth when we speak to halophytes. These are plants that can tolerate salinity in their environment. And lastly, another important one is sequestration of ions to the vacuole or to the cell wall. So plants can be broadly categorized as tolerant or intolerant to salt. So these are known as glycophytes or halophytes. So halophytes are going to be those plants that have undergone changes in their genome during evolution. And so these are plants that are adapted to saline conditions and can tolerate salinity up to 20 decisiemens per meter, so that a millimole per centimeter is a direct correlation to the decisiemen per meter reading. That is kind of a really good indicator of total dissolved solids. Halophytes are a small proportion of all plant species. Only approximately 2% of plant species are considered halophytes. A lot of these are going to be our succulents, and they have these reduced or succulent leaf structures, like in the aloe plant. We have reduced spines in the Euphorbia plant. The Apotinia plant also has a lot of adapted leaves in it. So some of these changes include active regulation of uptake, transport, accumulation, and utilization of ions in order to maintain osmotic balance and ion homeostasis within the plant tissues. And these plants do rely on ions for turgor maintenance. So the turgor is generated by creating high internal sodium and chloride ion concentrations. So these ion concentrations are actually going to be low in the cytoplasm and high in the vacuole. And again, the leaves are going to be reduced to small scale structures in some plant examples, such as Casuarinas, or spines like we see in the Apotina plant. The water storage structures develop in the leaves. They're going to have a thick cuticle, multiple layered epidermis, sunken stomata. The importance of that will come into play when I talk to glycophytes. And so they're able to avoid these high ion concentrations in the leaves through these evolved salt glands and salt bladders, which I previously mentioned, also through increased leaf volume associated with succulents, which we see in the aloe plant and other succulents. Conversely, with glycophytes, which comprise the remaining approximate 98% of plant species. So I have some examples here. We see, of course, our topic plant here, alfalfa, sorghum or milo, field corn, soybeans, grapes, and sugarcane. These are all plants that could be considered glycophytic or are sensitive to salt stress. So a high concentration of salt in their environment will decrease the soil osmotic potential. So these plants are going to be affected by ion excesses in the expanded leaves, as well as water deficits in these expanding tissues. So as plants are actively growing, they're most affected by salt in their environment. Photosynthesis, of course, will be inhibited with toxic ion accumulation within the chloroplasts. There is inadequate cellular compartmentation of ions in the leaves. This is a plant defense mechanism that I briefly addressed. And a high ion concentration of water in the cell's walls can decrease the cell turgor or the volume. So that affects the plant's ability to maintain its turgor pressure. Next, I'll be going briefly over some different plant defense mechanisms, elaborating on some previously mentioned evolved adaptive mechanisms here. So osmolytes are going to function to lower the osmotic potential in the cytosolic compartment through generation of active metabolites. So active metabolites are considered to be compounds such as proline, glutamate, sugars like sucrose and fructose, polyols such as sorbitol and mannitol, and more complex sugars such as fructans, trehalose, and raffinose, and ions such as potassium. Somatoclosure is another mechanism that's initiated through water deficit. So of course, stomate opening and closing is going to help generate the processes of evapotranspiration in the plant. So when we have somatoclosure, it generates this multifaceted feedback loop where the leaf and plant temperature actually increase, and this can cause photosynthesis to decrease or cease altogether. Next, ion balance. For example, potassium is essential for the maintenance of cell turgor, as well as membrane potential and the integrity and enzymatic function within the plant. So for example, excess sodium in the plant will displace potassium, which causes reduced protein activity. We'll talk through that in the research. And then supplementing soil with potassium can alleviate some sodium chloride toxicity. Lastly, leading into the next slide, increased reactive oxygen species production acts as a signal to reduce antioxidants. So ROS stands for reactive oxygen species. So these species are always generated at basal levels. So at a base level, they're constantly being generated by the plant. These can include singlet oxygen, as well as hydrogen peroxide, superoxide radical, as well as hydroxyl radical. So these are all the reactive oxygen species that are generated. So these are unstable compounds that damage proteins, DNA, lipids, and the balance of reactive oxygen species generation and scavenging of these species is disturbed by any source of stress. The survival of plants does depend on the capacity of the plant's ability to adapt to changing conditions. Other than hydrogen peroxide, reactive oxygen species do have a short half-life because plants scavenge and dispose of reactive oxygen species through antioxidant defense systems, which we'll talk about right now. So antioxidants will help to mitigate reactive oxygen species induced damage. So the free radical is stopped when that electron difference that's created through that unstable reactive oxygen species is corrected. Some enzymatic and antioxidants include catalase, peroxidase, ascorbate, peroxidase, and superoxide dismutase. Okay, I'm going to fly through the overview of the research a little bit just for time. I know we ran a little bit ahead, so I don't know, Jenny, if it's okay if I go a little bit over. I'm about halfway through. So just a brief overview of alfalfa and why I think this is such a wonderful crop and really promising for future directions as we are looking for different feedstocks within agriculture for biofuels and different crop rotations, important things like that that are starting to become more and more important. So alfalfa has a very deep taproot and produces a higher yield than other legumes because it is able to scavenge down deep into the soil profile and find that water source. So its ideal soil environment is going to be well drained, and it can, again, utilize moisture residing deep in the soil profile when there's not a lot of surface water available. This figure does a really wonderful job of illustrating the root structure specifically and correlates to the biomass production above ground in these different legume species. So the white clover is going to have a shorter root system correlating to less biomass production. Red clover is going to be the closest to alfalfa in terms of producing biomass. Alfalfa is adaptable to different habitats, and we're finding that it is more adaptable than previously hypothesized, and it can be used as a cover crop on its own or in a mix with other crop species and functional groups. So because alfalfa is a legume, it's good to mix it with other broadleaves, grasses. And the benefit of this is to reduce erosion and increase the yield of succeeding crops. And that can be correlated to the potential nitrogen credit that you get from the alfalfa presence on the landscape. One pitfall of long-term alfalfa production is going to be compaction of the ground, which is pretty well known and characterized. So the objectives of this study were to evaluate physiological characteristics of the alfalfa plants. This included chlorophyll content, the biomass of the plants, and survivability. Secondly, wanted to develop ways to determine protein content of extracted biomass through the bison-chondritic acid assay. Thirdly, we assessed the enzymatic activity of these reactive oxygen species scavengers, or the antioxidants, peroxidase and catalase. Lastly, the main thing we wanted to determine was whether some alfalfa variants are more tolerant to salinity. So I'm going to go through this pretty quickly. We got 4 different cultivars of alfalfa from Alforex Seeds, and they are a sponsor for this series. As you can see, this was a pretty substantial project. There were 50 seeds of alfalfa planted into 250 pots. So there were 4 genetically distinct varieties that we termed A through D. This was a blind study. I did not know which genetics were correlated to which variety. And we did get an initial biomass accumulation over a month initially. So we allowed the plants just to grow without any stress for a month and just watered them with from a hose, essentially. Just to illustrate the sort of tediousness of the project, alfalfa seeds, as we know, are super small. So I had some very patient graduate assistants that were undergrad assistants that were willing to count out 50 of these guys and put them into 250 pots. So the different cultivars that we were provided, and again, I only knew them as A, B, C, and D throughout the duration of the experiments. So cultivar A was known for its high yield, its persistence on the landscape, and its forage quality on saline soils. Cultivar B is categorized as having a high yield. Cultivar C is correlated with germination and forage salinity tolerance and high yield. Lastly, cultivar D was extremely winter hardy and had fast growth. So with the salinity treatments, we calculated out how the different millimolar treatments translated to parts per million and decisiemens per meter, excuse me. So this is talking to the specific salinity within the solution, not the soil. So these solutions, again, varied from 0 to 100 millimolar and varied from 0 to 5,844 parts per million of salts, or 9.13 decisiemens per meter of total dissolved solids, or the electrical conductivity. So 650 milliliters of treatment were applied to each pot 1 time a week over 8 weeks. So the chlorophyll measurement occurred through utilizing this instrument right here. It's called a SPAD 502 meter. It's an instantaneous measurement to tell you what the chlorophyll content is. It provides an index chlorophyll content reading from negative 9.9 to 199.9. An average reading that I would see would be about 50 to 70. And there has been a correlation between SPAD readings and leaf nitrogen content. So we use this because it's a non-invasive way to instantaneously measure the chlorophyll content in the leaf. Next, the sample collection of leaflets. So this was a pretty extensive endeavor as well to evaluate those physiological and molecular components that we were looking at. So these were essentially frozen in time as they were frozen at -80 Celsius. The leaflets were immediately put on dry ice upon collection, and they were frozen in time to preserve the integrity of the sample so we could get accurate enzymatic activity readings. Lastly, the dry mass collection, randomly selected pots from each variety and separated them from the soil, counted them for survivorship, dried them, and weighed them. Pretty simple. Biomass extraction, all these samples, the leaflet samples, were kept on dry ice until I was ready to prepare them for the extraction process. So they were ground with a mortar and pestle to a fine powder. After I removed the tissue into a microfuge tube, a sodium phos buffer was added and a protease inhibitor was added to the samples, again, to help inhibit the activity of enzymes. These samples were sonicated. That's what's happening here, in order to really get the leaf tissue sample incorporated with the extractants that we were utilizing. So after the sonication step was completed, we refrigerated we used a refrigerated microcentrifuge to get the supernatants to be removed for the peroxidase, catalase, and the BCA assays. So the peroxidase assay measured the kinetic evolution of absorbency. It was measuring how peroxidase would react and decompose in the presence of one of the reagents utilized called glycol, and this is a colorimetric assay. So as you can see, there is a colorimetric difference between the 100 millimolar treated plants versus the 25 millimolar treated. So peroxidase is involved in scavenging hydrogen peroxide, which is produced by superoxide dismutase, which is one of the reactive oxygen species. Peroxidase also plays a role in plant development, growth, lignification, cross-linking of cell wall components, and other things. Peroxidation is the main reaction of peroxidase in vitro with phenolic substances such as glycol, which was a reagent utilized in these assays. So next, the catalase assay measured the activity of catalase as the hydrogen peroxide was catabolized. So with these kinetic readings, we're getting, it's a time-wise progression of readings from the high point to the low point. And so there were some calculations that we had to develop in order to get it. And we read these all in quadruplicate. So as you can see in the peroxidase, it's an upward trend. The catalase is a downward trend. So catalase is important because it helps to eliminate hydrogen peroxide by directly breaking it down to water and oxygen molecules. The catalase enzymes are concentrated in the peroxisomes in plants. They're very important for removing high amounts of hydrogen peroxide, specifically in the shoots of alfalfa under salt stress. Catalase also plays a protective role for plants from lipid peroxidation of membrane systems. So lastly, the bisynchronic assay. The BCA mixture was added to plated samples in triplicate, as we see here. Again, this was a colorimetric, as we can see the color differentiation in our standard up top here, and then these are going to be the supernatant extracts of the different treatments. So here is the meat and potatoes of the presentation, the findings and future directions. So the effect of salinity on the biomass. We did find that biomass decreased with increasing salinity. And this is because salinity reduced the plant's ability to take up water. Physiologically, the plants did look a little bit droughty, especially at the 75 and 100 millimolar treatments. So this reduced ability to take up water results in reduced growth rate of the plant, as well as high salt concentrations. They build up within the apoplast, which is the cell, which leads to cell and tissue dehydration, causing that droughty appearance to the plant. And the salts built up in the actively growing tissues, which again will lead to reduced growth in the plant. Survivorship was variable between treatments and cultivars, and I hypothesize this may have been due to lack of methodology for determining survivorship from germination yield to survivorship. So the number of plants that actually germinated to survivorship at the end of the 8 weeks of treatment. Next, discussing the effect of salinity on photosynthesis. So because photosynthesis is a primary process affected by salinity, which we addressed previously, we did find the content increased with salinity as well as time. And this is well supported in literature. Chlorophyll content increase can be a strategy to increase carbon dioxide assimilation to mitigate sodium chloride accumulation within the plant. So increases in chlorophyll have been correlated to salt tolerance. So the capacity for the plant to sustain chlorophyll content is a critical adaptation for maintaining photosynthesis to support growth. And this is supported by literature that continued photosynthesis under saline conditions is an adaptive mechanism to tolerate salinity. Next, the effect on the antioxidants or those enzymes that are able to scavenge those reactive oxygen species and those unstable compounds. So there was a significant relationship between salinity, weak cultivar, enzyme activity of peroxidase and catalase. So these colorimetric assays were successfully developed to determine the activity of these specific enzymes. It was well supported that increasing salinity does lead to enhanced antioxidant enzyme activity in tolerant species and cultivars. Enzymatic activity, I determined, was going to be a useful biomarker for salinity tolerance, but it should be assessed in parallel with other parameters, as was done in this study. So lastly, the significance of this study. I was really pleased that we were able to successfully observe parameters of plant productivity under a saline watered environment. So we were able to determine which parameters were of utility and what needed development. Some cultivars did display well-documented characteristics of enhanced tolerance to salinity. All cultivars did show increased peroxidase and increased chlorophyll content. So the significance of the study, of course, as the population is increasing and the land that we're able to cultivate is decreasing, it's really important that we try to get a better understanding of what crops are going to be helpful in making land productive again. The mechanism of salt tolerance is not well understood. It's just another step. This study is just another step of putting the puzzle of salinity tolerance together. Future directions proposed would be identification of specific components or traits correlated to salt tolerance, maybe what genes can be manipulated to alter complex traits. And yes, I am referring to genetically modified. Salinity tolerance is best tackled through altering farming practices, which I will speak to in the next slide. So back to the complex traits and what's linked to salt tolerance. You know, we're speaking about what genetic transcripts are upregulated and signaling networks that are affected. So identifying these signaling elements and molecular identification and function correlated with the response to salt stress. Other things that should be identified are sensors and receptors for salt stress, as well as genetic engineering of stress hardiness. Alforex is doing a really wonderful job of that. So the implication for producers, salinity tolerance is going to be best tackled through altering farming practices. We want to prevent salinization or implement schemes to remediate salinized soils if there is a lot of salts in our irrigation waters. Planting perennials can help to lower water tables as that taproot is able to scavenge deeper within the soil profile. There is a significant impact of irrigation. So the long-term impact of saline in irrigation on soil quality, the volume of irrigation water required to return soil salinity to levels that are suitable for crop production, ideally less than 5 decisiemens per meter of electrical conductivity, thus utilizing less saline irrigation, especially when future rotations are going to include more salt-sensitive crops. Soil amendments can also be used, such as gypsum, needed to supply calcium and help to reduce exchangeable sodium. So with that free lime that's present in the soil, soil sulfur can also be used to reduce soil pH as well as solubilize native calcium in the soil. So use of these amendments can be essential when it boosts production costs, but due to the expense, it may not pay out. That first year, in the long run, it will though. Lastly, soil and irrigation water testing. How could I not speak to this piece representing Ward Labs? So soil and irrigation water testing on a regular basis is recommended in order to monitor salt buildup in the soil profile and also determine whether the saline water source, the irrigation source, is saline sodic, saline orthotic, in which case degradation of the soil structure is a concern. And if the saline source is high in boron, leaching would require higher amounts of water to leach. Just want to acknowledge some collaborators on this project. Of course, I wanted to thank Ward Laboratories for supporting me on this platform, University of Nebraska at Kearney, the lab that I completed my thesis with, the Biofuel Bandits, under Dr. Paul Twigg, University of Nebraska Foundation for Funding, as well as Nebraska EPSCoR. So that is the end of my presentation. Sorry, it was a bit long-winded. I had a lot to go over. Alfalfa makes me really excited, and the potential for it. So.
Great. Well, thank you so very much, Casey, for sharing all of that. I got to say, I am a bit of an alfalfa crop geek as well. So I recognizes like. So we wouldn't be here if we didn't all love this crop so very much. Folks, if you've got questions, type those in the chat box and we'll get to them right here. We've got one here. What about the use of humus and sulfur to break down salinity in the soil, Casey? What can we do there?
Yep. So we did speak to that. Those amendments can be utilized to help replace or leach out some of those toxic ions in the soil profile. So really it's about what is present and identifying what the problem is. So it just kind of depends on the context of what the issue of the soil or the water is going to be.
Okay. So I know that Ward Labs works tremendously well with their farmers that they work with, their farmers and their ranchers, and helping make sense of the data that you guys collect through the testing and everything. If I'm crop scouting my alfalfa fields, what should I be looking for if my alfalfa is a little bit stressed, or what should I do if I think I have a problem?
Yes. So, okay. I meant to point this out in one of my pictures. there was a photo of the alfalfa plant, and you can search this too. It's at the beginning of the presentation. I can describe it pretty well. So we'll see these white dots on the leaf area. That's going to signify potassium deficiency, and that sodium is actively replacing the potassium ion in the plant. So of course, potassium plays a significant role in turgor maintenance of the plant and other really important functions. So a potassium deficiency is going to be one way to identify it in the field. Another is going to be phosphorus deficiency. So potassium and phosphorus are probably going to be the two most important nutrients when it comes to deficiencies in alfalfa, especially as we face sodic or saline stresses in the soil. So knowing what excess ions you have is important to identify, and visual symptoms, so those physiological, visible things that we're seeing in the alfalfa plant and knowing what to look for are going to be critical in selecting potentially tolerant cultivars in the future.
Okay. It seems to me it's kind of like if I'm a high performing athlete and I get dehydrated and I use water and Gatorade. Something
Nice.
similar?
Nice. Yeah.
Okay. See, well,
because you're so like with the water, you're leaching out everything that isn't serving you basically. Water is a leaching source. And if we have excess dissolved solids and things like that, it's going to decrease not only the quality of the water, but the potential for it to supply the plant with an essential source of some nutrients. Sulfur is found in a lot of irrigation water and is essential, for example. So not all dissolved solids are bad in irrigation water. Ones that are definitely of concern are going to be sodium and chloride.
So we know that alfalfa has a tremendous profit potential for farms. We know that marginal ground, it can work very well for us on that marginal ground. So on a soil health perspective, it sounds like we can actually reclaim some of that marginal ground and put it into different production after we get done with some alfalfa.
Okay, so my rationale behind that and kind of my theory is that when we plant a field to alfalfa, and especially in a marginalized piece of ground, a ground affected by salinity specifically, alfalfa is able to scavenge deep down in the soil profile. It's able to scavenge down to a water table. It can help bring up the water table. This is specifically due to the perennial nature of alfalfa. So be extended potentially to other perennial plants. Perennial plants, I believe, are going to be really important in the future for food production, just due to the intrinsic nature of their persistence on the soil profile. They continue to grow. You can have multiple cuttings of alfalfa in a year if it's managed properly. And that's really the main thing. We have to consider how we are managing the alfalfa in our cutting schemes, right? So we don't want to be cutting too late, and we don't want to push the plant too much. It'll reduce standability for concurrent seasons. And a lot of times around here, issues I see are solely fields that are solely under alfalfa production for upwards of 7 years have terrible standability. The soil structure is really poor because it's compacted. There's poor aggregation. So alfalfa in a 2-year rotation with other cash crops, or alfalfa, planted with other perennials in a mix or annuals, really big on alfalfa in a mix. I think it definitely serves a purpose there. especially if we're in a grazing situation, because just growing alfalfa alone for multiple years is going to cause problems like any other monoculture will. We're learning a lot more about the problems of monocultures, specifically with resistance issues that are popping up. Continuous corn is an easy way for a lot of farmers in my part of the world to make money, but it is terribly detrimental to the ground. So that's just one example of why we really need to consider this as a piece of the puzzle for rotation in our management plans.
Okay. We've got on alfalfa rating charts, there's a column for salinity. What does the germination and forage rating indicate?
Is our Alforex guy still on here? Because he might be able to shed a little bit more light on it than I can. I'm just on this.
Yeah, this is Don Miller
Hey,
with
Don.
Alforex.
Yep.
Yeah, in the early stages of developing salt-tolerant alfalfa, we first looked at germination. And so some of the first varieties that were released just had germination tolerance to salinity. And then after we had those populations, then we wanted to tie mature plant tolerance to. And so on that national alfalfa variety list, you'll see a column for salinity tolerance. If it's G, that variety just has tolerance to germination for salinity. If it has a G and an F, it means germination and tolerance in the mature plant.
Excellent.
Well, there we go. It's always good to have Don on. He's handy. Folks, remember, we've got time for probably just one last question if you want to get that typed in here. I'm looking down here and don't think we have any more. Any final thoughts, Casey, as far as the potential of alfalfa as far as on our marginalized soils?
Yeah, so just a quick note, this study actually started out as investigating alfalfa as a feedstock for biofuels, and it just created so many more questions in terms of how we can use this crop, not just as a feedstock for our livestock, not just a feedstock for biofuels, but as an important plant species that is really, people don't credit it for its tolerance in challenging growing conditions. And that's due to its perennial nature, its deep taproot system, these intrinsic things about the alfalfa plant. Medicago sativa is just a powerhouse. And if we're able to further modify it to become more tolerant to these marginalized or saline compromised soils, as we know, this is a globally prevalent issue. A lot of places can only cultivate crops under irrigation, and some of that irrigation has a lot of total dissolved solids or has a lot of parts per million of some of these toxic ions to plants. And
when in doubt, plant alfalfa. Or at least that was always my dad's thought. When in doubt, go with alfalfa, because it is a crop that'll perform wherever you put it in it. Well, thank you so very much, Casey, for joining us today. And thank you for Ward Labs for bringing Casey to the screen for us. Thanks again. And I hope things warm up in the great north. Well, folks, that wraps up our second session of Alfalfa U today. Join us again March 4th, right here, when we are joined by Steve Norberg of Washington State University with tips on how you can use hay quality samples to fine-tune your fertility recommendations. Dr. Norberg will also update us on the future of alfalfa breeding and how the future quality traits breeders are selecting for right now can help you grow your markets in the future. We'll also hear from Dr. Ryan Larson of Utah State University, who's going to share the economic returns of steam technology. And Dan Undersander will come back to the screens and help us control our leaf loss during harvesting. That session begins at 10 a.m. Central Time, March 4th. That's 8 a.m. Pacific for those of you out west. And registered attendees will get email reminders and the session link delivered directly to your email addresses that you provided at registration. You can find the agendas for all 4 of our Alfalfa U sessions online at hpj.com/alfalfau. By the way, if you missed anything, we'll post those recordings of our sessions there for your review. And by the way, if you are still looking for CEU credits, please email Kylie Reese at KREISS@hpj.com. Kylie will help you out there, folks. By the way, shortly after this, you're going to receive a survey in your email boxes. And if you would, do us a favor, take a moment and let us know how we're doing and what we could be doing better. That's going to go a long way towards crafting next year's programming for Alfalfa U. By the way, all registered attendees will receive a complimentary 8-week subscription to High Plains Journal. Thank you again to our wonderful sponsors for today's session. Our premier sponsors, Alforex Seeds and John Deere, and our associate sponsors, STAHELIWEST, American Ag Credit, and of course, Ward Laboratories Incorporated. Well, folks, on behalf of all of us here at High Plains Journal, thanks for riding with us, and we'll see you on the trail.
Dirt road in a gooseneck, saddle up with me. Dry land in God's country, crops far as I can see.